Hey, nobody. So we're back again, working on some lower level video streaming protocol stuff in Go. So just a bit of an intro because I haven't done this really properly, and I think it's time to maybe make this stuff a little bit more official. I've actually added a bunch of current project info to anybody who comes in and watches and is wondering what it is that we're actually doing. So in general, what we're going to be doing is working on exploring software engineering through working on some of these video protocols that we see that we use like very often, all the time, even right now. I want to do it in the Go programming language just because I like it. I go to events, I sort of feel like I understand the language a little bit more, and otherwise I wouldn't know, wouldn't really know exactly what I was doing. So let me just, I actually made a little page just about what I want to be doing during these so-called streams. I don't want this to just be about writing web apps from scratch. I think those projects are really fun. I actually really like seeing those hobby projects, and I've certainly got a fair share of them myself. But I think it would be interesting just to do something a little bit more, I don't know, like educational, a little bit more kind of more focused on learning, both for myself and also for anybody else. Yeah, so it really just comes down to the difference between programming, like writing code, and software engineering, which is kind of all the stuff during and after, and the extra stuff. And there's a lot to that that I think would be, at least for some people, might be interesting. So, as I said, right now we're going to be working on some streaming protocol stuff in Go. So here's what we're going to be working on today. I don't really just want to read this out, but let's do it. So basically, SCTE 35 is a message format used to signal ad breaks to video players. So right now we're working on filling out more of the protocol. So we've got like the very bare bones of it. And what we're really doing is refactoring a open source package published by Comcast, which is okay, but I think it would be a good exercise to try and see how we can, what we can do to it beyond what is actually really running and working right now in production. In real systems, I know it's being used. So a little bit more about what SCTE 35 is, or SCTE 35. I'm not sure how you're meant to pronounce these things, but anyway. One of the common protocols used during streaming is called HLS, or HTTP live streaming. Very briefly, you load a line delimited plain text file, and essentially it contains a list of files, video files, that the player downloads and then actually renders, and so you see a bunch of images. The syntax here is totally wrong, but it doesn't really matter. Basically, you have, in these files, you also have these kind of things called tags, and one of the tags we can have is a base 64 encoded SCTE 35 message. So what we want to do is to be able to read this, decode it, maybe modify it, and then insert and then encode it and pass it on again to any players, or whatever else needs to be done in the live streaming world. We also want to be able to take a plain playlist, create a ad break, and insert it and then encode it again and insert it into the into a playlist. So the specification is kept in this lovely PDF file, which is I think something like 120 pages long. What I'll do is I'll keep this thing to the side and yeah, just work on it as we go. So let's minimize that for now and just get right stuck into the code. So just a little bit of the overview of the code where we're up to. The protocol seems to be, let me just see if we can see this. Yeah, I'm just going to get a little bit smaller if that's not too bad. There we go. All right, so the protocol really looks so far. Just open up the Go documentation just because I feel it's a bit clearer than the actual specification. Oops. Oh, great. Okay, yeah, always. Anyway, no, okay, we'll deal with that in a sec. So just to get an overview, so basically, what do we have here? What we're working through is encoding these Splice commands. So when you insert a message, what it encodes is a command which can be read by a player or an encoder or anything to signal a kind of an ad break or some whatever other information you'd like, really. So right now we're just working through the Splice commands bit. We've implemented Splice schedule, and if I remember rightly, we're going to be doing the Splice insert. So yeah, let's get stuck into it. So just trying to find the bit of the code that we actually got up to last time. I think it was here, yeah. Okay, so in this file command.go we've got types of commands, splice null. Let's see here, splice commands. Yep. So here's our spec, sort of. So a bit more. Yeah. So we've got here splice null, splice schedule, insert, time signal, bandwidth reservation, as we've got over here. So we've got encode command, which takes the command struct and puts it into a slice of bytes that eventually we will base 64 encode. So we've got our Splice schedule here. So let's see our Splice insert, or at least let's just check that we've got Splice schedule done, which is, a schedule is really just a slice of events that have a time or a duration associated with them here. Let's see whether what we can do with this thing. Just run a test just to see what's going on, where we're up to. Yeah. Yeah, okay, so we're up to so we got part of the way through encoding and insert command. And here's the old implementation from Comcast. Yeah, as I said, lots of code. Don't really need a lot of this. The problem is that because we're doing it all in one go, we've got a bit of namespace conflict going on because the splice insert is actually we've given that a constant value, which is a uint 8 or something. Yeah, so I'm just seeing whether we can delete all of this Comcast stuff now. Don't necessarily want to do that yet. So what we could do is actually just change the name of every basically just change the name of the, so we'll just change that to, just make it lowercase. There we go. And then we'll find where splice insert was actually defined in the first place. So type splice. Okay. Yeah, this is really going to be okay. I think what I'll do is I'm just going to comment all this stuff out because we can just look at it if when we need to. And the next thing, we've got the time signal, so let's also just comment this out too, so we can look at it again later if needs be. That one's, the time signal one's pretty easy, so I don't think we'll need to look at that later. All right. Okay, we've got a conflict here, so what we've got is we've got the, I don't know how to do that time signal. Maybe we'll do it trying to see what exactly. Just thinking how to deal with this thing, because we've got a constant called time signal and then we've also got a type. So I think for now, because we're not up to it, let's just call it that, and then I've forgotten to do our time signal. There we go. Those are all the command types. Let's close that. All right, just working through boring old compilation errors now. So our splice schedule, that's the type. Private. Okay. file now. Although an empty file. All right. Ready to rock and roll again. Okay. So let's work out how to encode this splice insert command. So a splice insert, we'll just go to the definition of that command. Splice commands, splice insert. Okay, here we are. So far here we're encoding the ID and the cancel flag, and then we're going through and we're doing out of network, immediate, rather we're doing the out of network, doing the program splice flag, duration, immediate, and then ID compliance, and the next 3 bits are reserved. All right, so if, I think we're up to encoding a splice time. So let's, and that's only there if the cancel indicator, is that right? Yeah, okay. Let's just do a blank line just to make sure, make it clear that we're not just setting flags anymore. Program splice flag. So what that means for us is immediate, like that. Since we're just using a time struct directly rather than managing a flag in our struct representation, because we don't need to have the booleans and stuff. We can just check if the value is 0. We don't even need to use a pointer. Using a pointer, then you get into all this problem of like having a nil pointer versus all that. We better to just use a value. Saves a lot of errors like that. Okay, so our splice time. What is a splice time? In our case, it's just a actual time, time.time in Go, but the way it's encoded is quite different. So I just need to double check what that is, because I can't remember, but it's something. Yeah, it's not just a it's not just like a Unix time where you just encode the seconds or whatever. It's something else. Splice immediate event compliance component. Here we go. Duration flag. Okay, I'll just look down here. Splice time. There we go. Yep. Okay. So splice time is a presentation timestamp. That's this PTS time. And that's this. Oh, I don't know if you can see that. Yep, my mistake. That's this right here. So I'm just thinking, again, I've already forgotten what that value really means in terms of tickets. Other programs, 90 kilohertz clock. Does that mean so really it's more of a duration. So yeah, and again, we've got this duration. So really, I think what we want is, I'd suggest what we really do want is a unique type for, you know, the number of ticks of a 90 kilohertz clock, because then, we'll need something like that, so that when we, because it appears a bunch of times in the command. So we've got things like it appears in break duration, a time signal command as well, splice insert. So yeah, we're going to have to, I think we actually did this before. We encoded a presentation timestamp, a PTS. What I feel like we need is actually and this presentation timestamp is actually pretty common in the, you'll see it also in the MPEG transport stream, which is used like a video container format that's used in the streaming world pretty commonly. So I almost feel like we need it to be its own type, not even in this package, but actually in, I'd call this streaming, oops, not this one, in this streaming package, which has a bunch of other media stuff in there, or at least not quite yet, but we'll get there. So yeah, almost. Yeah, so we'll just need to think of a way to represent this thing. There's a, I think we dealt with it somewhere. Was it break duration? Yeah, this is it. Yeah. So the break duration, yeah. So here's a 33-bit. Here's our 33-bit field. So what a break duration is similar to the splice time, but yeah, just slightly different representation. One can be nil, the other can be null. or empty. But essentially it's like an array of 5 bytes. I think there's 740, yeah, so 40 bits, 5 bytes. So I think what would be clearer here is actually this duration would really need to be, instead of just being a plain unit 64, we could represent it as perhaps an array of 5 bytes. So say, let's see, so let's do a new file called time.go, and then let's put in our so this will be a PTS, and what that is an array of 5 bytes. So that'll hold all the information we need. And then from there, we'll have some functions that convert between a duration, which would be, the number, in this case, the number of ticks, and how to pack that into the bytes. So let's say so we'll say this. PTS represents a presentation time stamp, which is the number of ticks of a 90 kilohertz clock. And then say we want to be able to take a duration. So I'll just call it this for the moment. So duration is a unit 64 or 2 ticks. Anyway, no. And then the number of ticks, yeah. So, or we could call that count, but let's just do this. And then that gives us a PTS. And then we can put all of this encoding logic in there for the most part. So, so let's go from there. So P, is that PTS? So let's start packing the bytes in. So we're going to go from we'll do the here's more bit packing logic. So let's put this in. So we've got byte of the ticks, and what we want to do is okay. Look, let's leave that first byte for now. Let's just do these ones because this is going to be easy. So byte p dot duration of ticks. Uh, 24. There's our now the thing is that gets us 32 bits, but we need 33. So I think what we want to do is we're going to use a mask, bit mask. So what we want is our number of ticks is a uint64, so the number could actually be pretty big. So, but what we really want is say with a We're going to need 1, 2, 3, 4, 5, 6, 7, 8. So what we want to do is create a mask that's like that. So mask, and then we're going to need the bytes. So we're going to have the so our first byte is going to look something like shifted. We're going to go 33 along, but then we need to mask off these bits. So this is a bit where I'm hoping somebody comes and helps, but I think it's going to be something like it's something like that. And so what this really looks like is our first there. I think that's right, but I'll just need to think about it for a bit. Yeah, okay. Hey, how did I learn? Well, I've been working as a in like the computer world for about 10 years, I think. But yeah, I just started at a small IT company doing like sysadmin stuff, like doing at a Linux place. I was doing a lot of Linux, so just doing shell scripts and stuff like that. It was a small company, 10 people, and yeah, eventually learned a little bit more and more about programming, essentially through just reading open source code and doing, your own implementation of something. So for example, say I wanted to, rather than downloading some program to do something for me, I try and write just exactly what I needed, so a really small program, and often that would be enough for whatever I needed. The same goes for really a lot of things, like even in the sysadmin world, downloading these big installation scripts, or like Ansible playbooks or Terraform modules, all this sort of DevOps stuff. Often when you're doing projects in the real world, you can kind of write something up yourself that could be a lot smaller. And if it's clear and well documented, it's probably okay. Yeah, so as time went on, I just did more and more programming projects rather than like that kind of sysadmin DevOps stuff. Yeah, that I'm sure I could go into more detail or not, but yeah. But thanks for the question. Let's do that. That's clear. I'm going to need to write some tests for this bit because I'm not exactly sure that I'm getting the value that I want here. I'll just need to double check. So what I often do when I'm testing these things is well, you know what, we can use a Go playground. So play.golang.org. So what I want to test is that my bit masking logic is, see if I understand it well. So what I have is a really, really big integer. So let's say like 987654321, something like that. And then what we want to do is make an array. Oh, thank you for following, whoever just followed. I'm not sure how to see this stuff. I really suck with Twitch, so yeah, sorry. Let's see. Yeah, but thanks. That's cool. Hope it's interesting or useful or anything. You know. Let me know what you want to see. By the way, like I'm just doing this just because I had a random idea one day, and a lot of the open source stuff really helped me learn a lot. So I thought I should try and make whatever I'm doing open source as well, just to pay back. Speaking of which, the code that we're working on is actually follow along. I'll just say, I'm hoping that whoever's watching this actually has the source code, which is available here. So what I'll do is I'll try and pin that message. I know something went wrong, unable to pin. Okay. There we go. All right. Hide. All right. Yeah. All right. So what I would normally do here is let's start. Oops. Oh, sorry, that sound would have been really bad. I just realized my microphone fell off, but anyway. Sorry. I just... All right, try again. So what we're doing is packing a part of this 8-byte value into 5 bytes, because what we really want is a 33-bit integer. So if we were to pack all 40 bits, we would do something like this. 40, and then down we go. So what we're doing is we're shifting 8 bits at a time, and then grabbing the next 8 bits. So that's 24, 16, I think this is. Oh, I've done it wrong, obviously. 2, 24, 16, what have I done wrong? 1, 2, 3, 4 equals byte I, 8. No, that should just be that, so I've done something wrong here. So 8, 16, 24, 32. Yeah, that gives us 40 bits. Yeah, that's right. So let's print every one of these. Right. So that's 40 bits from this from this integer. 8, 16, 24, 32, 40. All right, great. Now the thing is that we don't want 8 bits from this particular byte. We only want 1 bit because we've got a 33-bit integer. So we've got 8, 16, 24, 32, and then 40. But what we can do is we can mask, do a bit mask. So mask ID 1, 2, 3, 4, 5, 6, 7, 8. And then if I remember rightly, we can do something like this. So what we want is, let's actually and then mask. I think that should get us what we want. So what this is doing here is we're getting the we want is to zero out these bits and then only get that bit. So what we're doing is we're doing 1 and 0 added together is 0 because 1 and 0 are not the same, and then we go through. So it's 0, 1 and 0, 0, 0, 0, 0, 0, 0. I think. And now let's print this. So after mask, and then we'll just print the 1 bit, that first byte, and hopefully we get, I want to see just that value. No. So it's byte and in. Oh, okay, so there's a byte. I think. Excellent. Okay, I think we got it. So after masking, the 33. Yeah, we can't really represent it, but it said 33 bits. I'll just B, yep. So all of these values should be the same as here. So let's just check. So we've got 1, 0, 0, yep, 0 and all ones, 0 and all ones, 3 ones, 3 ones, and then OB01. Okay, great. So just to make it, maybe this is clearer, just getting rid of that OB thing. Let's see. Oh shit, I just realized you can't see. Sorry about that. Ugh. Okay. There. All right. So let's do our mask. So mask. Byte is, and then do this, and we'll just do, oops, PO, so PO, and equals mask. Great. do here. So we want to extract. So this is P0 is actually 32. 24. 16, 8, and then 0 here. So we're not importing anything, so we can just do that. So we'll do mask off the 7 bits. $33 total. Not 40. No. Put that up here just to be clear. Is this because it's 40, 32, 24, 16, and then 8. Yep. All right. Let's okay, so we'll just do this. So as a 33-bit field there. That's really what we want. As a 33-bit field. The number of ticks of a 90 kilohertz clock All right. And we'll also want a function, I think, that goes the other way. So we want to take a PTS, so PTS is PTS, and then convert it back to a uint64, so you can just do like easier operations on it. If you want to add like 500 ticks or whatever, then you can just do that without, you know, stuffing around. So we're gonna I'll just try to remember how to go back the other way. So we're going to have a array of 5 bytes. I cannot remember how to do that, so I believe the Go standard library has a bunch of stuff for that. So I think it's in the binary package. Encoding/binary. This is the one. Yeah. Uvariant encodes a uint64 from buff and returns that value in the number of bytes read. Okay. One, two, three. So this shouldn't be too bad. So we're just going to take a uvariant. So we'll go. Actually, do this. So we'll go in equals binary dot uvariant, and it's actually going to be a slice of byte. So we're going to convert the our array into a slice. And then we'll just cover these cases. So, although do we really care though? That's the thing. No, I just don't think we care. Just try this for now and just see. Okay, this looks like a good opportunity for a test. So just to test, so what we'll do is we'll go from the number of ticks to a presentation timestamp, and then back again to a number of ticks, and then we'll see whether the values are equal or not. So there should be a test. Okay, so what to do is we'll do a number of test cases. So do so we'll go 1 and then 128 and then a big number 987654321. Oh no, sorry, no, we'll actually do the maximum value, or at least something close to the maximum value of a 33-bit integer. So what is that? Well, let's see. So that'll be 2 to the power 33 minus, let's just do minus 100. So that's that value there. So okay, now let's go. So for count range ticks of the count, and then for underscore count. And then let's just print that for now, just to see what we get. Sort of, or rather, we'll do print each of the binary. Yes, and then close that. And then let's go back again. So t equals ticks of PTS. And so now we can go, if the values aren't equal, then we're, and that's sorry, we're going to go, no, let's get this right. Yes, if t does not equal the count, equals t want so that'll be ticks of, so the input was PTS, the output was T. What we really wanted was count, and then we go, let's just do that, that's good for now. And see what we get. Not call non-function ticks. Looks like a function to me. Oh, okay. Yeah, okay, let's just fix this up a bit. So okay, and then is not what we wanted, which is TT, then well, there you go. Yep, all sorts of problems there. Not too small. So I did need to test this panic. I'll just do that for now, just because I'm expecting it to fail right now. Or not. So what we've got here is we pass in a slice of 5 bytes to this uVarInt function, and then what we get back is zero. What we wanted was not zero, not at all. 128. So quite sure what's happening there. Let's look at how this uVarInt function actually, let's look at its implementation. See if you can see that. Oops, not quite. Looking at this. Something to do with the order of the bytes? That might be it. So, I don't know. So we go PTS4. I mean, I don't know. I'm kind of a bit lost here. 3. Is this going to be? No, that's. No, I'm a bit confused by that. So the issue is that we're getting parsing, or not parsing, but anyway, like we've got a array of 5 bytes and we want to get a 64-bit unsigned integer out of it. But I thought that not the word, totally failing there. Is there anybody I can ask? I don't think so. Equals 0. So yeah, so we've got the something to do with this. I might not be doing that correctly. Maybe I could just really want another way to convert or rather just understand more about converting a slice of bytes into that type, or really any type. So let's look at the yeah, okay. Yeah, right. So I think that's a special kind of event. Yeah, right. Okay. So okay. Great. Okay. Somebody comes to our rescue is awesome. Yeah. So yeah. Okay. I'll just put here so we can see exactly what. Yeah. Unsure about the endiness. I can't remember either. There was a thing about that. Oh no, I can just read the. Let me just check the spec. They might have something about it in there. Nope. No. Maybe as long as it's I'm pretty sure it's little endian just because that's what those are the CPUs that we're dealing with. Is that correct? yeah, pretty sure. And I know that the, at least I know that when I've, yeah, and also the Comcast package, they also did it in little endian order. So let's give it a go. So we'll just go back to the documentation here. So little endian, I think, was a type up here, constant variable. Yeah, that's it. Append byte order. There we go. Looks good. So let's do that. So we've got binary.littleendian.uint 64 of our array, and then there is only one value. So I think we can just go like that, which doesn't even require a function. But anyway, let's little endian, and then little endian. Okay, so now what I can do is I can make our buffer as like append 3 bytes, or prepend 3 bytes to the buffer, and then go from there. So we're getting so what's happening is that the range range 7 with length 5. Yeah, so maybe we can do something like this. We can do is a byte of length 8, and then, or rather, cool. Thanks, Nid the noob. Thank God for the noobs out there helping the serious actual noobs like me. This will start with 3, and then we'll append our timestamp, okay, looks like we've got it the wrong way around, so we'll do let's just do it like this, and then we'll also from 0, 1, 2, so from 3 I'll do this, and we'll do for J, and we'll range over our PTS, and then we'll do set all the rest of the bytes, so buff I equals equals PTS, and then where we're up to, and then might get us there. Nope. Try the other way around. So first we'll set an array of, set a slice of bytes, and then append 3 onto the end, zeros that are, because we don't know what these things are. Not quite getting there. What we'll do is maybe it's stumped. We can put it in there. Is that what we want to do? Put you in 64. Return anything. Into I, and then return I. How to convert byte slices into 1632 or 64-bit integers. Yeah, tricky. So we've got that. So that just checking this example. So the tricky thing there is that I don't understand that. A uint16 is just 2 bytes. So if you give it a slice of, this is a slice of now 4 bytes, and you're putting that to that value, then yeah, quite get that. UN64, yeah, that to me seems like the right one. Yeah, UN64, 64, yes. Okay, let's look at the implementation of this type here. Not that type, sorry, the little endian. Variable little endian. Okay, so we can't see it, but that's okay. So yeah, this is the one. yeah, so I've I messed something up a little bit here. 64 of that, so we can't possibly do that, so big number. Could build it up like this, because yeah, and then just use this thing. I'm literally working with bytes in memory. Yeah. Yep. Yeah. That's right, lots of math to read a single line. Yeah, it's yeah. I think what I can do is I or equals I think something like that. What do you think, Chandy 16? Am I think, how does someone get started with this stuff? Well, I think we're doing it right here. There's a bunch of stuff about, I think what I found quite difficult was these sorts of operators, these bit shift operators. It's a good question, yeah, like bit shift. There might be some good tutorials out there on bit shifting. It looks quite confusing, and it is confusing. Oh, shifting operators. Okay, cool. Oh, well. How does someone get started with this stuff? Oh, you mean maybe do you mean these streaming protocols, like in this thing in particular that I'm working on? How would someone sit and write code to move bits and get some sort of work done? Oh, like, do you mean maybe why some sort of work done. Not quite sure what you mean about that. Yeah. PTS function, okay. Yeah. Yeah. Okay. So, okay. So my understanding is, I think, the value that we want, this, this particular value here, we're given a 64-bit unsigned integer, and we want to convert that to a 33-bit field. So that means basically, moving along, and then so we get 40 bits total, and so we make an array of 5 bytes. First byte is going to be the first byte, or rather this byte of ticks, and then the second byte is going to be this one, third byte that, blah, 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 blah. So the reason why we have this thing is because of, no, I've never written assembly. Oh, as in you mean like WebAssembly or just assembly? No, never written either, yeah. I think that would probably help a lot if I did. So so what I'm doing now is I'm basically going the other way. So given this array of 5 bytes, I want to convert that to a 64-bit integer. And I'm not 100% clear. I don't know how to do that. Yeah, I think this actually looks, you know what, I think this one here, I'm not sure if we can see that. Yeah, here we go, so I'll just, oops. Sorry, there we go. This stuff here. This looks about right to me because we're going to go through each byte and then set the values of each byte of the uint64. That to me looks about right. So the difference is that because we haven't got that many bytes, we've actually only got 5, just because this is the type of value that we're working with. That's that PTS, the presentation timestamp. So what I'm going to do is, I'm just going to go along like this, and then just make sure that we're shifted to the left because we're going along the bytes. Even 64 PTS2 shifted left. Oops, no, like that. Yep. So we're converting that into a UN64 and then shifting the whole thing along. I think that's right. Yep, so we're just going to keep going. 3, 16. Oops, got this wrong. 8, 16, 24, 24, 32. So, oops. And that. Yep. No, still the same, yeah, same thing. Yeah, not sure what is going on here. In 64, yes, no. Oops. Big endian maybe. Could be big endian. I think we're big endian. try that. Yeah, I think that's it. I think we're big end in. So that's 4, 3, 2, 1, 0. Ha. There we go. We got it. Great. All right. Yeah, whew, finally got it. All right, so I think now what we want is yeah, damn. Okay, let's close that. Let's go back to where we were a long time ago. So it was this splice insert. Yep. And a splice time. So a splice time is structure. So this is important to put this here as specified in SCTE 35 section. We've got 9.8.1. You know what? That isn't even. I don't think this is even important either because we've got the time. Okay, so this could either be, this structure when encoded could be either 1 byte, so 1 plus 7, 8 bits is 1 byte, or it could be 8 bytes, 39 plus 1, 40. So What we'll do here is not have that. So the splice time, what it really what I think would be useful for us as a consumer of the package is really just to have a the splice time is really just perhaps a pointer to a presentation timestamp. That way we can check if it's nil and set the flags accordingly. We'll know whether we even need to. I'll just double check. So yeah, if inst.splice time, okay, then we go down. So if inst.splice time don't equal nil, okay. Now we get our now we pack up our actually, let's do the easy one first. So let's go if it is nil. I think that's enough. Yeah, because if it's nil, then we just move on. So we'll go back. If splice time is nil. Oh no, sorry. Okay, so not equal nil. And okay. And then we go down and then we go splice time. So splice time is there, that. So what we want to do, we can just encode this structure just in one go here. It's a weird structure. I don't quite understand this. So even within the splice time, we need to say whether the time is specified or not. It's kind of, I don't quite understand that. Yeah, so I think now we can just safely start appending the bytes straight up. So we can really go sorry, no, this is wrong. So we need to do, all right. So in here, we want this to be a ticks. And this, here we go. And this is the, number of ticks of a 90 kilohertz clock. Okay. And then we encode that into a, I would say duration like this. Oh no, break duration we've already got. Okay, whew. Okay, let's call it splice time. Okay, let's just call it that for now, just because it's the same as in the spec, and then if we need to go back and rework it, we can always quickly just find exactly what we're looking for. All right, so our so now we're going to take our ticks and put it into a PTS. So PTS equals to PTS of our splice time, and then append it to our buffer, which is going to be PTS ... And we could really just put that in one there, but yeah. Although quite yet, and now we need to set this time specified flag. So we've got, this gives us 40 bits, but we'll need to set that bit there. So what we're going to do is, so we go set time specified flag. So that's PTS or equals the one shifted to the left, since it's the in the leftmost position, so it'll be 7. Yeah. Okay. Great. Okay, next up is the duration flag. Okay, we need to create a break duration, which I think we've already done. So let's just double check. So break duration. Yep, so double check, break. Yeah, again, it's the same thing, so should really put, yeah, we'll want to merge this logic here. Yeah, anyway. So this here should really be a, yeah. So let's just do that, is that right? Yeah, we want to do this. So PTS is the 2 PTS of the duration. This is the, again, number of ticks of a 90 kilohertz clock. And then Yeah, that looks good. And then we just go down from there, but we don't need to do any shifting anymore, so we just do PTS. 1, and then, yeah, okay. Yeah, is that really better? I don't know, I'm not sure. Anyway, we could tidy this up. Yeah, that seems right. So that, next 6 bits, okay, do that, and then 1 bit remaining in the first byte, that's P0. Pack 1 bit from the timestamp, because we've got 33, not 32. So we'll pack that all in like that. Great. Okay, looks good. Let's just do that test, and we'll just knock out the printing there. Great, so we don't need that debugging. Great, all right. Okay, just double check. So, oops, we need to pack that in buff equals pen buff for PTS. Okay, and again. Okay, almost done with the splice insert. So now we're going to move on to the the unique program ID, and this stuff we've already done. So what we might do is just check. Yeah, easy. So we can just copy it all along here. So we'll just grab this. Oh, yeah, let's just tie this up. So buff equals append. It's a program ID, is that right? So we'll check. Insert program ID avail, yeah, okay, so it's all the same. Avail, oh, yeah, let's just make that the same for consistency, so avail num. Okay, and we'll grab these. Just the insert, yep. Here. Oops, no, this is outside of that. So we only do that if the cancel is set. Yep. So this is, yeah, so we, oh no, let's have a look. Oh no, sorry, no, yeah, that's right. So if Yeah, no, that's only there if cancel is not, so that is in here. Let's just get that and we'll just do oops, append. Oh man. Thought that'd be wrong. Anyway. Append buff. Program ID, val null, val expected. Okay. And we're on compilation stuff. If Splice on not equal nil, mismatch something, and untype nil. Okay, so the tricky thing here now is that we've got, we need to work out how to set the, whether to use whether to have this as a pointer or whether just to have the, have a Boolean flag here. Not really sure how best to do this. So if it were a pointer, then when we're packing it, we can just check if it's nil and then set the flag and encode the value. But the thing is that, you know, that's, yeah, having a pointer, you know, nils and all this sort of stuff, it's kind of gets yucky. I'd like to be able to, yeah, avoid a lot of that stuff. But to avoid it, we need to have another flag here. For example, this flag would be the program splice flag. So program splice would be a Boolean, and then, to be honest, that's more work by the consumer of the package. So for example, if you were making a insert, so for example, if you just had a literal, like you say, you know, insert equals insert, and you're making this thing, and now let's say you do, you know, ID is 134, cancel is true, and then you do this, splice time would be, you know, let's go 5, 6, 7, 8. Now when you encode that insert, we wouldn't know necessarily that we'd actually want to encode it. So here we've got the yeah, so I'm just thinking how to do this. I feel like I might need to use a pointer, but damn, a pointer just for a number. No, I can't do it. I'm gonna have to do it like this. So, because that means that as a user of the package, you can just set the splice time and then know that, well, I've set it, therefore, however encode works, I don't really care. It'll just encode it properly for me. I think it's going to have to be like that, because otherwise you get into the condition where you set a splice time, but you forgot to do, say, for example, this, use splice. then that just sucks, right? Because then then you can have that, and then it's a nil pointer, and no. Okay, no, we've got it. So let's yeah, that's a good point. The splice time can be 0 as well, I think, although it's really rare. Oh, no, yeah, you know what? That's a good point. Very good question. Some noob you are, shit. Yeah. So what it represents is a duration. Sorry. No, it can be 0. Yeah. Yeah, the value can be 0 because it represents at what when exactly this message should be acted on. And how these clocks work is that they just go round and round. So you've got, it goes up to like the maximum value, which is whatever the maximum value of a 33-bit unsigned integer is, and then it'll go back down, and then it'll roll over, and it'll go to 0, and then round it goes, and then 0, and then round it goes. So 0 is a possible and like a valid value. So yeah, that means that I think we're going to have to use a pointer. Does that sound right? Yeah. Okay. So dereferencing here, so there. Whoops. Okay. We wouldn't use the splice time. Yeah, there is. You're right. Yeah. Yeah, you wouldn't use the splice time if the let me get the documentation up. So if immediate is true, then you don't set a time because you just want it to happen as soon as possible. So when you send the message, the encoder or the receiver just says, oh, okay, I need to do it as soon as possible. That instead of 0 splice time. Okay. Damn, this is a clever noob. Who is this guy? Jeez. Okay. So, in that case, splice time could be, okay. Splice time could be nil. Okay. So, well, let's see. So let's say I'm doing creating an insert. So I'm doing ID, whatever. Let's say cancel is, okay, in this case, let's say, I think this is actually valid, which doesn't, oh, no. cancel indicator is 0, and if yeah, so this is that is a valid, this is a valid message here, if you can see that. And another one would be and then yeah, I can't remember what the type looks like. Immediate. Yeah, I don't know, it doesn't matter. Immediate. Oh no, sorry. Event ID equalizer, no, it doesn't matter. Yeah. Then we'd start with the duration or the yeah, so either yeah, so you can, and then you can set both break duration and splice time. So these are the situations that we've got. So splice time, say is a you know, whatever, and then break duration, and then that's just another one of the values, one of the fields, and then this itself is actually, you know, the same, could be another number, like for, this is again actually specifying the ticks of the clock. So those are those are really some test cases that these are the things that would be test cases. Break duration. So could it ever be nil and so could the splice time be nil and we try to access it? I guess so, if somebody forgot, if they did that. Because this is valid. This is also valid. And this is also, so that's valid, and then also this is valid. That's valid too. Okay, so if inst2 and inst3, would they have a different meaning? or different behavior to the thing. Well, when it's encoded, it looks different. Yeah, that for sure, because yeah, because here we'd need to put in 5 bytes. And this one we wouldn't have 5 bytes. And that, you know, and well, I mean, and you'd know that in advance when you're parsing it, because then you know, you have these flags set. So you kind of go along your bytes or in bits and say, oh, this bit is set. Okay, then that means that, you know, the next, my next bytes are going to be a splice time. So now, would they have a different behavior at the by an actual encoder or a player? Yeah, by a player, yeah, because when say you're watching a video like in VLC or something, it'll see, you know, my clock is up to 0, and I know that I've got to insert this. I've got to do something when my clock hits 0. Whereas in this one, it won't. It doesn't care. Yeah. It's disappointing. Yeah. But then at least, as I say, at least with the pointer, you know, we don't have to, you know, the user doesn't have to worry about setting the flag themselves. And of course, there's just less, you know, this is a good point. Yeah, it's less exposed overall. So the you know, how it's encoded and the wire format, that need to be exposed. In Comcast's one, it was all exposed, and I mean not only exposed in terms of actually being in the struct, but actually it was exported. So yeah, no, we don't really want that. We don't care. Users don't care about, you know, it's a implementation detail that, you know, the code is meant to take care of for us. We can work it out. You know, the code can work it out. We don't need a person to do it. All right, so yeah, so let's break duration, really? Duration. Okay. No, we want that. Yeah. Okay. So duration. All right. So, oops. The duration. expected. Oh, avails expected. Oh dear. Okay. Avail. Like that, and then just make it consistent. We don't need the avail expected. Excuse me. Insert as avail expected. Great. Whew. Okay, that is another one of the commands done. So, if you look at these, we've got splice null, schedule, insert, done all those, time signal, and then we're actually done. So I did private command, sorry. So time signal is actually just our splice time again. So encode, let's go back to here. So our command, our time signal will actually just be a pointer to a pointer to a just a pointer to a uint64 I think would be okay. So I'll just see. So I might just put this down into a function because it's splice time, and this will be a tix uint64. And so then we can just put this into because we need to set this time specified flag, and I guess look, so we can do it like this. So this gives us a we'll just copy and paste, so that, like that. Okay, and then we'll set the time specified flag. And then return that. Okay. Okay, so let's go all the way back up to our command where we encode the command. Okay, so let's add in our splice insert. That's that. B equals encode insert, which is from insert. Great, okay. Now our time signal. And that is just oops, what do we got? Command is okay, so this isn't, that's going to be a pointer to unit 64. Kilohertz clock. I feel like I could actually, because the type, I'm not sure whether the name time signal to, because we've got that in the type, so I almost feel like we're going to put this as just, oh no, anyway, sorry. Okay, I think we're done. I think we've encoded all the types of commands we need. Here's an error. Oops, if c dot time signal but no value, no time signal value set, but nil time. So this is c dot type, and then that's it. All right, there we go. Okay, convert that to a slice. Okay. Whew. All right, so just to review what's happened here, we can go back to here. Let's just so all of this can go. Splice insert. Can go splice. Other bits that can go. Break duration, I'm tempted to just put into that command file. I don't think this gets us anything really, having a separate. Yeah. I'll leave it for now. So, encrypted packet, delivery restrictions, no, private descriptor. Oh no, that's a different part of the specification. Different part of the spec, splice descriptor, different part of the spec, info section. good. So let's just see. All right. Great. Look at that. Null scale dependency reservation property command. Yeah. Yeah. And then wow. Okay. Oh man. 1,800 lines of code. Okay, so we've it started at over 4,000. We're down to 1,800 lines. With 0 dependencies. So we've removed dependencies, which like themselves have quite a bit of code, and then down to 1,800. Yeah. Yeah, that's right. It is awesome, yeah. Oh, yeah. Obviously, we need to put some more tests in. So, oh, sorry. No, you know what? Even more. No, let's just get rid of more. There's more to get rid of here. Hold on. Yeah, we've done all that. Yeah, so that's easy. RM time signal. What's different? Oh yeah, no. Okay, let's get rid of more. So oh, okay, yeah. Oh, it's all commented, but yeah, okay. Anyway, yeah, that's good. Yeah. 500. Whew. Yeah. That's yeah. To rename that to that, and then we'll just do that. Yep. Great. Okay. It's 12:15 midday here in Australia, so I'm going to quickly grab some food. And we'll come back and just what we should probably do next is encode the bit where the command is contained, which is this Splice info section structure. So we've done all this. So yeah, let's set myself to be right back like this, and yeah, be back in I don't know whether I'm meant to eat in front of this or not, but I might just go for a quick walk around the block, and I'll be back in about 30 minutes. Thanks. Just actually what I'll do is I'll set a time. So like, how do you do this? That's 1:01:45 UTC. And we're all nerds here. We know what UTC is. Yeah. Great. Okay. See you in a bit, whoever's there. All right. Oops, sorry, forgot about the microphone. Hey, this through. Get us set up. This one goes. Okay. So I'm just going to update this message in the pinned thing just because okay, and then I'll pin that, and then I'll not pin it. I don't know why this pinning keeps failing for me. Alright, pin. Great. Great. Seems about right, I think. All right. So what I want to do now is work through encoding a Splice info section, and that way we can get our first proper end-to-end tests going using the examples that are actually in the specification. That'll be really good because then we can, just be sort of sure that what we're doing is, actually good, or at least actually works. All right, so let's have a look at this Splice info and Splice info section. So this Splice info section, let me just get this in the Go documentation, might be a bit clearer. So what we've got is all right. Splice info, and then we've got here the Splice info section, which is from the Comcast package. So do is probably just looking here, protocol version. So it looks, Geez, yeah, it's a lot to this stuff. There's a lot going into one message, because got all these you can see Splice command, but then there's also a descriptor, and then there's a bunch of metadata and actual data. So what I'd like to do is just Let's just start working through this splice info. So the splice info that we've got so far is not quite complete. So what we're going to want is something Alright, so let's do a new function, encode info. So the first byte is always going to be at least the length is always going to be 9, 10, 12, 24, 30, 31, 37, 70, 78, 90, 102, oh wait, let's just build it up like this. 8 plus 1, 2, 4, 14. 1 plus 1 plus 2. No. 8 plus 1, 2, 4, 14, 22, 20. I'm got this right. 8, 9, 10, 12, 24, 32, 39. Section syntax indicator. That should always be set to 0.
Okay, so we'll just leave that bit. Private indicator will always be set to 0. Okay, so we skip that as well. So then we go on to the type, which is 2. Okay, so so what I'm doing here is just working out how to exactly set these bits nicely, also with these constants. So I'm pretty sure that because it's a bit field, but then the values are, yeah, I think we'll, because essentially we've got a, so next 2 bits, let's write this down just so, table ID, no, section syntax, okay, section syn, let's get this copy, okay. So now we're on to the, so the layout so far must be 1, 2, 3, 4, 5, 6. There we go. So that means that each of these next 2 bits are going to be these. So for close is going to be, the mask is going to be OB. It's actually going to be just that, because it's 0. So type 1. So and then this leading is going to be, we're going to take the value of one shifted to 3 positions, all right, or 2. Yeah, 0, 1, 2, yep. Open gob, it's going to be one shifted 3, and then it's going to be what's that going to be? So geez, I'll check what this actually is. Don't quite like the look of this. So like that. So what's that value? That would be good to know. See if it might be clearer like that. I don't think so though. Oh, is D12. Yeah. All right, well, that's that bit done. Let's have type section length. So we've got 1, 2, 3, 4. Got 12 bits spanning across, of course. So we've got 4 bits. So what we've got left are 4 bits. Now this is the actual length, which we haven't got yet. So we'll need to, we'll leave that to the end. So, because rather, we don't know how long the whole thing encoded is going to be until we've packed everything in. So because we've done the command, and we're just, what else have we got? Command, and then other variable length bit will be doing these descriptors here. So yeah, we'll need to leave, yeah, anyway, we'll set the length at the end. So let's just see what this protocol version is, because that's the next thing that we need to do. Bit of a pain because these, you know, 1, 2, 3, 4. Yeah. All right. So, oh no, I'm sorry. 2, 4, 16. Oh, great. No, okay. So we can just move straight onto the, which byte is that going to be? Be 1, 2, 3, 4, 16. So that's 2 bytes, and we've done the 0th byte. So let's go. So that's the 1 and 2, and that's just a to-do. Anyway, okay, so let's go protocol version. So that's our next thing. It's a single byte, nice and easy. Protocol version. At present, this attribute shall be set to 0. Okay. So let's do, we can add this here. I mean, because it's going to be, whether we leave a comment or a explicit thing here, I think let's just use the constant. All right, so let's move on. Next up is protocol version encrypted packet. Okay, so this is a flag. So this will be something like, so in our struct, let's just get rid of this stuff and that, and that. Let's get our type, find our Splice info. So essentially, if this thing is true, we're going to set the bit. However, we might be able to not bother with this flag and just use, just check whether this encryption algorithm is 0 or something like that, which would be better because then we don't have to worry about, you know, the user of the package actually setting a flag or not. So let's just see. This cipher is a, could use a pointer, or let's just keep it like this at the moment, and then we can always simplify. Well, yeah. Let's just write some code, eh? Always better to write something down and delete it later. The trick is to delete it later. That's the big bit. So then this, and then we're setting the 7, and that sort of final bit. And then I'm going to see how to encryption algorithm. Okay, that's 6 bits. So that's the stuff that we had here. So let's see, call that the cipher type. So we've got 0, 1, 2, 3, and then nothing. So let's just see how we can encode this thing, or if we might just be able to just we might even just be able to do this. Although it would be good to check that the value of the cipher actually fits into 6 bits rather than this could be 8 bits. So we'll just check that. I'd like to check packet. So we could do a bit of input validation here and just say so let's just do check here if cipher greater than or equal 64. Yeah, and then we'll just return null at the moment anyway. So let's throw back an error and say yeah, so actually let's okay, so this is a good point about clear error messages. So this is one of those times where you don't just want to say invalid encryption algorithm, because what is, like, why is this invalid? Like what's bad about it? What I also see here is that, say if we want to print, you know, just for debugging or anything really, the ciphers, we've got some of them here, but we haven't quite got everything, because the values greater than 64, or 64 and over are actually invalid. So what we can do here is we can do so if C is greater than or equal to 64, that's, is that right? Yeah. So let's do this, else if C is less than or equal to 63, then this is actually user private. finally, everything else is invalid. Outside valid range. This is getting a bit long, but yeah, yeah. Let's say outside max. Yeah. This is a tricky bit, right? Outside max value. Could even have this as a constant. Yeah, let's do that. Let's have a constant there, that's good. Oh, I don't need that. Is 63. Right, so as is max cipher. Larger than max value. Okay, percent %d. There we go. There we go. That's better. Oh man, programming's hard. All right. So we've got 63 or 64 here. Okay, we've got it set here. No, here we go. Greater than. Okay, there we go. Max cipher. There we go. Oops. Oh, right, yeah, okay. But we don't actually just want we don't want the byte value, we want this to be set as the 6, let's get this right, the 6. Oh no, I think that's correct. Let me just double check. Yeah, because we've got here, if it's encrypted, we're going to have this value. We're going to have 1 and then x 2, 3, 4, 5, 6, 7, and then afterwards we're going to have a value of like some whatever fits into here. But we're going to have to actually shift that. I still think we're going to have to shift it. Yeah, we're gonna have to shift it one along because, I'm getting confused now. Where's Nid the noob when you need him, man? He was super helpful. It's yeah, it's difficult, this stuff. I might need to what we could do with a test here, I think I'm gonna have to do a test. Because confusing now, it's definitely going to be confusing later. So let's go import testing, encryption. All right. Oops. So let's say we've got a Splice info section. Let's just make one up. So Splice info, and the encrypted is true, and then the encryption algorithm that we're using, let's just pick one. Let's do the triple DES. Yeah, let's do that. Okay, so triple DES. All right. So what we want out of this, I'm pretty sure. Let's just specify what we want. So what we want at the end of it is that bit set to true, which is 1, and then we want the next 6 bits that value. So that's 0, 1, 2, 3. Okay, so that means it's and 3 in binary is help me out here, somebody. 1, 2, 3, 4, 5, 6, 7, 8 is actually 1 is 1, 1, right? Yeah, 1, 0, 1. Yeah. So the value that we want here is going to be 1, 2, 3, 4, 5, 6, and then 0. That's when it's packed, that's the value that we want. So let's test for that. Let's work out some logic to pack it like that. So let's just get a byte, and then and it's just if sys.encrypted, and then we'll set the first bit is 1, 7. Also, let's just do this if b does not equal 1, and encryption impact got a b 1 a b and we want. Okay, there's our little test. Is that what word on this? Encryption algorithm. Tempted to change that to cipher, but anyway. Oh, B, yeah. Okay. Types byte and int. Okay. Byte. Go. Great. Okay. Makes sense because we haven't packed in our cipher type yet. So we have. Let's just explain this. So we want. No, that's fine. We've got that. No. Oh no, let's just say we just set it to let's just put out the whole logic here, and then we can do more test cases. So switch of the encryption algorithm. Oops. Okay, we'll go through the cases. So cipher none is nothing. ECB. Be that many times. Case of CBC. Oh, sorry. No, I think. Oh yeah, no, that's right. Yep, 5. I think. Ooh, I've got this wrong way around. Anyway, let's just yep. Let's just see what we've got. Oh no. Oh, I've totally got this wrong. I need to do, yeah. Yep. Good, makes sense. So let's see if we can shift that to 2 positions. No. So the first bit is true, and then the rest is yeah, and then we've got 1 bit left over. That's the definition. We've got 1. Yeah, I'll have 1 and then 6. So whatever value we let's just do this. So, yep. Okay. So that passes, but I don't think this is super clear. So okay, let's define some more tests. Right, so tests equals array of splice info. Oh, all right. So this is a good thing. I don't know who or if there's anybody watching, but this is a good doing these so-called table-driven tests. So anyway, the idea is that you just enumerate a bunch of different sorry, I'm not doing a very good job explaining this. Whoa, I've totally forgotten how to do this. Yeah, okay, so type is a splice info, and the value that we want encoded at the end, so that'll be a uint8, let's say. So and now we can just go. So our first test case is going to be a splice info encrypted true, and then the encryption algorithm is going to be, let's choose this. Okay. So is case is going to be okay, and then so in this instance we've got encrypted to true, and then we've got the next 6 bits, 1, 2, 3, 4, 5, 6, and then the final one, or the first one, whichever way you want to think about it, is 0. So this value here, our 6 bits, in the case of it being DESCBC, which is 2, so it's going to be on 0. Do another one. Just do the same thing again. This is a new test case now. We're going to do here triple DS, and then the value that we want at the end of that is going to be this thing here. Okay. So let's knock out all this stuff and now we're going to loop through the test cases. So for range case, range tests, okay, and we just get all of this here. This means the point of this is to make it easy to add tests later, or modify tests, and yeah, just see what we're doing. All right. Oh, phone. 2 seconds, let me just grab the phone. Oh. Right, hey, sorry all, whoever, no, we've lost some people, whoopsies. Okay, all good. Just this back here. Alright, so, okay, let's do um, okay. Yep, looks good. So what we'll want to do here is always shift the value that way. Yep, okay. All right. Yeah, so this is a time where I don't know quite where to exactly put that, because when we encode the splice info, there might be quite a lot there. So this should be like a relatively big function, just because we have to encode quite a lot of things, you know, and errors and stuff like that. So And a long function is okay. You know, it's just straight up top to bottom. There's not anything too tricky going on. So a long function is it just means it's long. It doesn't mean that it's complicated. That's probably one of the big things that I always think about. It's a useful test though, just because there's a little bit of that little logic there, so I'm not quite sure how to do this. What we've really got is yeah, not sure how to do this. 51. Okay, so one thing we could do is we could have a new function in, oops. Let's call pack the cipher. So say we have a, cipher gives us a byte, and then we always want the first bit toggled, because that means that yeah. Anyway, let's just give this a go. So we're going to toggle the first bit, 7, and then we want to pack the rest into 6. The next 6 into the next 6 bits. So the C, but actually shifted 1 over. Final bit reserved for, whatever. Something like that. Next field in Splice info section. I'll do this Splice info there. Okay, and then return B. That seems pretty trivial, but I think You know what? I'm not sure I even want this in a function at all. Because it's just this, and then yeah, shifted one. That's just like that. And that's better. Stop this. And then we've got 1 bit remaining for the PTS adjustment, which is Splice info, PTS adjustment. There we go. All right. Great. PTS adjustment. So, if I'm not mistaken, PTS adjustment is our old friend, the presentation timestamp. So, let's see. Subtype, section name, protocol version. PTS adjustment, 33-bit unsigned integer. In the clear, that shall be used as an offset to encrypt this message. Okay, great. So let's we've got a uint64, but it should only be a 33-bit integer. So let's put that in there. Sensing number of ticks of a okay. Okay. So okay. Oop. That's fine. Okay, and then we're done with encrypted packet. So let's put the test over here and make it clear. All right. Equals. PTS becomes the to PTS of the PTS. Okay, now we need to pack everything in. So, so let's get this right again. So the 4 equals the byte of the PTS. Oops, no, it's shifted 32. Is that right? Oh no, we can just get the I think it's just that. Because what we're doing is setting the we've this byte that we're dealing with at index 4, we've already set a bunch of values. So our presentation timestamp is 5 bytes. I think we have that somewhere. Yeah. Yeah, so we've got 5 bytes. So this one I think should be, I'm just getting confused on the byte order, that's all. So we've got, we've packed a bunch of bytes in. Not quite sure. Let me see, what I'll do is I'll just review this to PTS and just see, because we'll have, yeah, in those 5 bytes is 33 bits that we care about, and I just can't remember which one is going to be the first one or the last one. So PTS. Yeah, it's just, yep, it's just that. Okay, so now we can just start adding the rest in. Oh no, now we can just do direct assignment because we know that everything fits perfectly into a byte. So this is going to be pretty boring code, but easy code, right? Or simple code. Okay. Oh, sorry. 1, 2, 3, 4, and then we've got one more. Oh, 4. All right. Now, okay, look, we can tidy this up. Let's, because we actually need a few more bytes here. So we've got 3 bytes, so we're starting on the 4th one here. So let's add another byte, equals append buff. And then go here, and then we'll just okay. So now let's just add another now we can just append the next bit of PTS, so it's from 1, oh wait, no, which way? We can just get a slice, so we can go from 0 to the end of it. So we're just stuffing it all onto the end of buff. I can't, again, one of the Zeus's, can't remember the slice. So we're going to do, let's say we have a array of ints for, and then of, I can't remember how to slice. Oops. Yeah, okay, so what I'll do is so this should be 1, 2, 3, 4. Yeah. Awesome. All right, so we'll go from 1 onwards. Excellent. Okay, we can knock out all that. Okay. Hey, new viewer. I think there's somebody. I don't know how this Twitch thing works. Like whether when somebody comes in, like can you see who it is, or do you get a notification that somebody joins? Because yeah, I don't know. I think it's cool that somebody is even clicking on this. It's crazy. Anyway. So coming back to packing this splice info, so we've now packed the PTS adjustment. So next up is this CW index. I can't actually remember what that is at all. Let's just have a look. Which control word key may be used to use a decrypt message. Yeah, look, let's just, I think, yeah, I'm pretty sure we can just throw it in there because because we've done 740, yeah, so this is just a plain old byte, so let's just go of the CW index, so it is. Splice info CW index, okay, whatever that is, no idea. Tier, all right. So what's tier? Tier is a 12-bit value. Just let me see if you can see that. Oh, my bad. Okay. There we go. So the tier is a Okay, so a 12-bit value that we want to put in here. Hey, new viewer, or at least I don't understand how these viewer things work. I see the number going up and down. I don't know what it means, but anyway. So 12-bit value used by the message provider to assign messages to authorization tiers. Any value between, okay. So it looks like this is going to be this really needs to be a uint 16, and then we'll just mask off the 4 bits that are invalid. So first let's add the tier to our struct, and then set it as a uint 16. So for some reason I haven't got it here, but anyway. So splice info, next will be our tier, to uint 16. I'll just make an explicit note here that it's a 12-bit, so holds a 12-bit field. Representing an authorization tier. Yep. An authorization tier. Okay. so next up we're gonna, so let's create, first we can do some value checking here, because say if somebody sends in the max value of a UN16, we want to error out really. Yeah, because it's one of those tricky things. You don't want to just like slice off the value and then pass it on. You know, it's a bit, yeah. Especially because we're already returning errors here. So it makes sense that, you know, we have the opportunity to, so, you know, and the caller can always just ignore it and just pass it on anyway. I think, anyway, we'll look. You know, if they're sending bad values, we should tell people that they're setting an invalid value. So if, so the max tier is going to be a constant which is going to be the maximum 12-bit value unsigned. So is that going to be, if anybody's here who can talk about this with more authority than me, but I think the max value for a 12-bit unsigned integer is going to be 2, like that, 4095. Just to confirm, we can just do a quick test, because we know that the maximum value is, OXFFF. So let's just print that out. Nice. Okay. Great. Power 12 minus 1. Okay, so if tier greater than max tier, then so just the error message. What's a good error message? You're going to be something like I don't know whether to print this out as a like an integer or as hex. So that'll be still not sure whether to return nil or the buffer there, but anyway. I'll return nil for now, just because that's what we're doing everywhere else. Great. All right, so let's get some bytes. So we're going to have, oops. What have we got wrong here? Cipher. Oh, okay. Sorry, this test is failing now just because we moved the packing logic for the encryption out of the, or did we? Yep, all right. Let's just put this here then. So so we're just toggling that bit, and then we do b equals byte of the cipher that we're using, or encryption algorithm, nice and long, and then shifted that to make room. Okay, great. Okay, where were we? Yeah. Okay, so now what we need to do is pack the this tier, which is a 12-bit integer. So what we've got, well, let's just count where we're up to so far. So so we're going to need another one of these length things, but this should be easier now. But anyway, either way, our tier yeah. So look, I really want to just want to have a function for now. I know it's going to be an array of 2 bytes. So let's see how this thing packs up. So we want the left of these 2 bytes. We want the leftmost, all the leftmost bits be this from the tier, and then we just want to mask off whatever's left. So I'll just do and then we're going to what are we going to get after this? So we've got our first byte is going to be I need to get the order right here, but it's going to be of tier, and then shifted 8. I think that's right. Okay. But this isn't correct because we've only got, we need to, well, in here it should only be 12 bits. We're only allowed to set 12 bits. So as a bit mask, that's going to look like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4. Yeah. But that mask is going to be, we need 2 masks, or rather we just need I know. Certified to success. You know, there's certain skills that are required to do this kind of work, and I think, you know, counting from 8, 16, 32, yeah. It's yeah. Somebody's got to do the hard work, you know. So the mask that we actually want is going to be 1, 2, 3, 4, 1, 2, 3, 4, like that, which is just OXFO. Yeah. Something. Fuck, I don't know. I'm anyway. No. Byte of that, mask with the mask. Okay, and then we're going to have a test here because I have no idea what the fuck I'm doing. And I need the computer to tell me whether what I'm doing is okay or not. Splice. I'm just seeing if we've got another file already, but PTS. Yeah, look, let's just do a new file. Okay. All right. So let's do a test, which is the let's say our test case is just going to be the max is going to be the max tier -1, just because then we know we're going to have a whole bunch of bits set. So let's so what we'll do is we'll pack our bit field and unpack it, and then if we do not have this value, then we know we know that I'm really dumb. So that value is going to be so we've got our array is the, I'll just do packed equals the packed tier of 1, and then we'll unpack. I need to unpack, or oh no, we can just I know how to do this. How many have we got again? 12? Yeah. Yeah. Okay, let's just do it. We're just going to do this for now. Okay. All right. Yeah, exactly. All right, so we have, that's the value that we want. So let's learn how to pack this thing. So the first byte is going to be our int16 shifted 8, but then mask off something like that. So oh, oops, no, we want this. Sorry, so we're going to be printing out each bit of our array of 2. Okay, so we've got, when we get these bad boys together, let's do that. So 1, 2, 3, 4, great. So we definitely got that. Okay, that actually looks correct. So, oh, wow, we got loads of people here. Hey, man. All right. Yeah, so here's our, so we're just packing everybody who's here. Geez, there's a lot of people here now than there were like 5 hours ago. Maybe I should do a quick intro if anybody wants. If anybody wants a quick intro to what we're actually doing here and why or anything, then just let me know in the chat. And really, like, shit, anything you want to see, just throw it in there, you know? Like, let's see what happens with this thing, hey? Anyway, so back to what we were doing. Yeah, I am. Yeah. Ah, okay. Yeah. Hey, hi. Okay, I am Australian. Yeah, I'm in Sydney in Australia. It's almost 2:30 p.m. here. Would love if it was why you chose Acme. I think Russ is the only person I know that uses Acme. Yeah, I get this question. Acme, if you've heard of Plan 9, I think I always read about Plan 9 and think, oh wow, like this is a really cool bunch of really cool ideas that I'm really interested in. And so using Acme can get you, gets you a little bit of that Plan 9 feel because, you're dealing with, text streams. Everything, the editor itself is represented as a file system, so writing little programs that can be used in Acme are just super easy because you're just writing, bytes or text to files. So creating a new window just means, echoing some text into a file, and bang, you've got a new window. What made me like the Plan 9 feel? I think I actually didn't. What made you? Okay, so I like the Plan 9 feel because when during work and stuff like that, you see Unix itself is really old, and when you're let me put it like this. I don't know if you guys use Linux, but I remember installing Linux for the first time when I just used Windows as a kid. And Windows felt really, after I installed Linux, it was like, whoa, like Linux is super inconsistent. Windows suddenly felt super inconsistent. Now the thing is that running Plan 9 feels like that again, but it makes Linux feel really inconsistent. Plan 9 has a whole bunch of problems. It's super slow. A whole bunch of weird stuff about it that yeah, it doesn't. Yeah, it's a lot of weird stuff about it that I think shows that it's just for research, not really for real world use. Things like how easy it is to write software for it or port stuff to it. I write in Go because I feel like there's a sort of like that brutal consistency in a way. Like it's Plan 9 is also really dumb because in Plan 9, like everything is almost everything is represented as a file system. So and all of that works with the kernel actually speaking this protocol called 9p, and so yeah, so a lot of the ideas around concurrency and stuff like that, I mean, it's totally what you see in Go too. Yeah, so yeah, I really recommend looking into it. I often like read the manual pages or see how something's done in Plan 9 just because you can see they'll implement something in like a tiny number of lines of code. And yeah, when you're looking at how something's designed or how much stuff do you really need, often you can look at Plan 9 or just the same as when you look at the Go standard library. Like sometimes it's surprising how small some of those things are. Yeah. Yeah, so yeah, it's good stuff out there in the world. Amazing software out there. Yeah, wish I could say I wrote some of it or I could understand it more. That would be cool. Yeah. Oh yeah, just pulling half it. Yeah. Yeah, well, I mean, yeah, oh really? Yeah, there you go. Yeah. Look, I mean, yeah, it is, and it's a cultural thing, I think. Yeah. Yeah, I think it's a cultural thing. Like, yeah. These Plan 9. Yeah. Yeah, it is weird Plan 9, but I think nowadays, like, perhaps it's more relevant than it was because, with everything running in like the cloud and, network connectivity being so common now, having an operating system that's really like is a distributed, like really is designed to be run in a distributed environment, like separate bits of computing connected via a network, it seems pretty relevant now. So when doing things like Kubernetes, I think sometimes looking at Plan 9, you think, oh wow, like, Kubernetes is, a really big system and it's just getting bigger. That Plan 9 is a whole operating system in like a fraction of the lines of code that Kubernetes is, and Kubernetes needs, a whole, operating system underneath it. So, yeah. Yeah, yeah. It's pretty good. That's good. I wanna. Can you pin? I'm just sorry. This is like the third time I've used Twitch in my whole life. So, that's good. Can I do this? Cause yeah, here we go. Yeah. That's good. Okay. Yeah. So, no, that's interesting. Yeah, the dependency thing. I know. Yeah. Well, this is, you know, uh, I don't know whether you guys have seen what we've been doing so far, but this package that we're working on was 4,200 lines, and now we're up to got it down to 1,800, and we've also removed the dependencies. So yeah, I mean, that's yeah, it's definitely possible if you yeah, just think about it a bit differently. It's a bit annoying because right now we're dealing with this bit masking stuff, right? Like it's like, oh, and I didn't do a computer science degree, so I'm not sure that one, so that would go. Yeah, right, there you go. Interesting. Okay, so it's like really hard to bring in the dependencies. I'm not surprised that wants to leave that go. Oh well, there you go. Yeah, look, I've yeah. Go wild, hey? Yeah, so yeah, you do that. You have to maintain them. Ah, okay. Yeah, I gotcha. So I guess they'd vendor everything. I guess the thing with dependencies or getting rid of dependencies is so let's say this particular package that we're dealing with here, I'm hoping that it's clear to see. I'll just put this here. So like this package is used in production, rather the Comcast package, so that's the one that that's available over the internet. Like in the broadcast systems that I know where this thing is used, when is that thing ever going to be updated? You know, like it's just never. So the thing is as well is that then the dependencies of the Comcast package, they're also never going to be updated. Now, we know that the Go project works really, really hard to, you know, for backwards compatibility. And I know myself, I've, you know, wrote code and, you know, come back 2 years later, and I compile it and install it, and it's still absolutely just fine. So that's a, yeah, that having done some JavaScript stuff too, I think anybody else who's familiar with JavaScript, yeah, like it's just a totally different universe. The motivation for this project is, well, yeah, learning for sure. Yeah, sharing stuff, having different conversations about things. Here in Australia, it's kind of hard to find other people who are working on stuff like this too. So I figured, hey, like if I just start doing this, then maybe I'll like learn about what other people are working on too, and like get new ideas and stuff. I also think that there's a group. Is this it? Yep. So, yeah. Well, there's definitely more kangaroos. I mean, there's actually too many kangaroos over here. It's a real problem. Especially now that, you know, like around, you know, in the countryside and stuff, there's been a lot of tree clearing over the years. So there's loads of grass, and you know, kangaroos love that. So they kind of they're very happy with all that. So there's a lot of them now. But yeah, this video dev group, it said video engineers, whatever video engineer means, and yeah, I feel like it could genuinely be useful, because a lot of this stuff, when I've done projects in this sort of streaming space, these some of this like proprietary, say you need to communicate to some system using a SCTE 35 message, like the implementation on the other end is really hairy. Good question. Yeah, so unfortunately, it's because of this shitty tracking stuff. So the idea is that you put a signal in there, and then the player will load something as directed from somebody like Google Ads, or like who knows what, something that is targeted to the person, or also is just like, say it's nighttime, so you need to play a different ad because whatever, or in a different language, for example, stuff like that. Yeah. Indistinguishable from normal video files, so it can't be blocked. Yeah, I can't remember. I'm not familiar with like by an ad blocker. Yeah, I can't remember what the anti-ad blocking measures are, nor how the ad blockers themselves actually work out blocking those things. I know there's work. I know there's like industry groups that try to block ads and stuff. Sorry, block ad blockers. Yeah. That's a good question. I actually don't know. I would be surprised if they weren't. But I'm not sure. So actually check, right? We can go. Now, by the way, I'm not actually sure how do you play your own thing, channel? Here we go. All right. So if I load this and then let's just see. Woohoo! Okay, what are we getting here? Test stream segment. Okay, so here's our. Here we go. So here's our TS file, which is an MPEG-2 transport stream, and what we're looking for is. Whoa, geez, there's loads of people on here. This is weird. Okay, so. Let me just see the file that they've. We're looking for the playlist file. Now I don't know if they're using HLS or if they're using another. If they're using MPEG dash, they could also be using that. I'm not sure. Oh yep. Yeah. Here we go. Okay, so here we go. So let's copy that in here. Boom. All right. So this is only short. Usually what you look for is like the master. they call like the master or like the main playlist, from which all these other ones are fetched. Can we filter by the date? What's the type here? MPEG URL. Oh, they're using their own custom tags. Yeah, you know, that's actually a super good question. I think TTVNW.net. Let's see. So what we're trying to do is see whether they're using oops, TT. Oh, they're using Go. They're using Go there, I think. So let's see. Let me do it like this. There we go. Bang. All right. Oops. So then let's say we grab that one. I want to look for is it? No, I don't remember how it's in there. Anyway. I can't remember how exactly it looks like. We can probably find it. Carry SCTE35, use these attributes. Let's look at the HLS. So what we're doing, we'll just read the HLS spec and find exactly, here we go, date range. Ah, that's it, date range. X35. Date range. It could actually be this. Oh no, maybe not. All right. Okay. They're out there. I don't know if we should keep continuing with what we were doing, or yeah. All right then. So let's see. Okay, so where we were up to is, what were we doing? Splice info. Yeah, that's right. Yeah, we were packing this 12-bit, like encoding this 12-bit integer into the into this. So what we'll do here is see how exactly to let's get a nice test on this thing. All right, so let's just get a test going here, just so we know going forward how this thing works. So just thinking how to do this. So we've got a value of wanted thing here. And then let's so we've packed the thing. Let's unpack it again and double check that we've got exactly the same value that we had before. So that'll be, yeah, I think, yeah, that's a really good question. Okay, so I don't know, basically. I know that when I was packing, when I was like getting a 33-bit integer, then I needed to do a big endian. So here was a so I was doing the binary encoding, so that was byte order, big endian, where is that? Oh, anyway, yep. Sorry, let me just find the previous example. here. So these presentation timestamps needs to be big endian. Now, why or yeah, I can't remember exactly why. Is it because that's the order it's transmitted over the network, or I can't remember. But either way, let's just do. Yeah. Okay. Yeah. Yeah, defined like that by somebody. Yeah. The thing is that I can't, at least how I've read the spec, I can't find any information about that. Yeah. Yeah. Okay. So it's just just somebody just says, okay, it's going to be big endian, and then that's just whatever. Yeah, you go from there. Okay. All right. So let's grab our array and grab out the numbers of it. So it's going to be a uint 16 of the pact O, and then ordered with the uint 16 of the pact 1, and then shifted 8. No, except it's the other way around. So 1. Oh, this is tricky. Okay, so shifted. Is that right? 8 or? Right, let me look at how I did it before. So here I've gone this big endian, I think, if that's right. So we're going to get the byte at index 1 and then 0, yeah, but then and then shift it along to the next 8 bits, I think. So yeah, that's right to me. Okay, and then so let's go now. If 1 is not equal, oh sorry, not equal 1. Go pact. Let's just start with that, and then we can add some. Okay. I'm not sure whether this really needs its own function, but because that's really just parsing even. Oh. No, it's fine. So we have our tier. So if we go back to this beautiful specification that I'm getting sick of now, tier is just about done. So yeah. All right. Okay, so let's get this. So tier equals of our tier. And then just check which bytes we're up to. So we've done all of these bytes, and yeah, so it's all aligned. Okay, so we're good to just I think we're good to actually just append those bytes as is, I think. But then shift, okay, but then shifted 4 along. So we're going to do like this. So f equals append, no, wait, sorry, let me get this right. Yeah, we'll need to shift because, yeah, we want these bits to be the leftmost bits. So we'll need to make sure of that. So we'll go tier, how do you do this again? Maybe we can just do it 1 byte at a time for now, and then get a way to do it more simply. So tier oh, this isn't looking nice. That's 3. I don't like the look of that. I really don't like the look of that. We've got 12 bits. So we've got, yeah, no, I don't like the look of all that. We need to fix this up a bit. So yeah, or at least I used to, but I've actually just started looking for work again. So, and because I was getting bored doing resumes and CVs and stuff, I decided this would be a better use of my time, and maybe somebody who's watching this wants to hire me. That would be cool. Oh yeah, absolutely. And cover letters, and a cover letter for each. So 4 documents is better. Printed, you got to print the resume, print the CV, print the cover letter, and then scan the back in again, and then email them to somebody. That's I think that's the proper way to do it. Yeah. No, I think that's good. Yeah, maybe, yeah, damn. Ah, okay. This is too real, guys. It's too real. I don't want this much reality, okay? Yeah. Well, yeah, I mean, it's good. Pigeon GPT got involved, it's like Bird AI, you know, which is good. You know, you need that now. I think you need, you know, these AI, which is avian intelligence. You need that involved in the hiring process. So yeah, I think the courier bird actually sounds like a really good idea. I've never thought of that, but thanks. Yeah, that's. Yeah. 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 All right. Oh, I think. Oh no, everybody, right? Everybody loves dogs and popularity, right? The most important thing. All right, so. So the next thing here is what I'm trying to get at with this little bit of code here is, say we've got a say we've got this value. So whoa, how many? 1, 2, 3, 12 bits. That's good. And sorry, yeah, so 12 bits. But really we've got 16 bits available to us, or rather when we're packing it we want to have, you know, really we've got 24 bits, so. That's good. That's funny. That's good. All right, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then the next 12 is going to be like. Yeah, somebody else said that. I've actually never done assembly before. I know with Zig and even with C, you can define like bit fields as their own, you know, as like a discrete type. I think that would be really useful here. But with Go, no, don't think we can do that. Is that right? I've never done assembly, so. Yeah. It would, yeah. Yeah, okay. Yeah, it would definitely make the code clearer. I mean, just to be able to. Yeah, I think. I don't know that the order bits might be different. Okay, yeah. I mean, other. Oh, yeah, okay. Yeah, right. Okay, so so correct me if I'm wrong, but would that be something like, say you have a type that's like a 12-bit field, you'd have to say, oh, the order of bits is this or that when you specify the type. Maybe it's a comment or I don't know, something. Oh wow. Yeah, that's cool. Celebrate user code A at 0. Ah, okay. Right. Ah. So the architecture, like the CPU architecture, so yeah, because isn't x86, that's little endian? Is that right? Shit, yeah. Hey, that looks clean. This that looks much nicer. Yeah, okay. One, two, three, four, five, six, seven. Oh, right. 4, 8, 12. 1, 2, 3, and then 4. 9, 8, 16, 24. No, that's it. Yeah, 3 bytes. Yeah, yeah. It's actually not a bad idea, yeah. Yeah. So what I'm looking at here is the next 24 bits. This is the next 3 bytes. And just seeing exactly how to pack these things inside an emulator. No, just my just in text editor, yeah. Like it's running. I'm running what I'm running on my Mac now. Yeah, yeah. This is just a yeah. It's kind of like a weird text editor. I'm not sure if you were here before when we were talking about the text editing stuff. But yeah. How do I follow people? Can I do this? Like, how do I like add you people to like my my list or something so that I don't know. Is it? I don't know how you're meant to use Twitch. Like how you're meant to use these things. Like if I add, like, do I follow? Follow. Oh, it's because so how do I and he goes, oh, okay, yeah. Well, I don't know. So then do you? Oh, well then, okay, sweet, cool. Okay, well then I'm gonna undo it. I don't know how. Oh, yeah, unfollow. There we go. Okay. Otherwise, I'll get confused because yeah. So if I yeah, okay. Yeah, this, so that I remember that. Like who I've spoken to and stuff like that. There we go. Nice. Okay, I think, yeah. VIP. Is there VIP? Is that what is? I don't know what that is. Sorry, I've never. Yeah. Okay. Oh, okay. All right. Okay, so let's make this thing. All right, so just here, just trying to work out I got this human 16, so 4095. Oh, equals max 4095. B I. Okay, and then we'll shift it. Three. Oh, right, yeah, no, I always want to print 16. Okay. So what I really want to do, I think then, is shift 4 along. Yeah, there we go. Okay, so this is so here I don't think I actually want to thinking what would be ripples are useful. Yeah, absolutely. So based on this, I'm a bit lost now. Sort of, not really. Nah, not lost. Okay, so I've got 2 bytes. I want 12 bits. I want to pack the next 12 bits. So yeah, I think this is right. So is that what is that? SHR4. No, nah, 100%, man. SHR4. Yeah. I don't know, keep thinking out loud. It's good. Yeah. So because okay. So what I'm trying to do is I've got 2 bytes, and what I want to do is put so what I want to do is pack the pack these 12 bits into the next 2 bytes. So I've got a 12-bit integer, and then I want to put that into the next 2 bytes of this buffer. I just can't remember which order I want to do it in. So OXABC, OXAB, OXC, okay. Okay. Yeah, I guess so it's like the opposite way around, yeah. So here then, do I want to Oh no, I know. I need to do it like this, I think. And then get this one, but then shifted. Pretty sure that's it. Because then the next 4 bits have to be from the next field, which is this splice command length. So right now we're doing tier, and after that we're going to move on to the next 12 bits here. So I think that's right. I think. Nah, I've got it wrong, because I've got the order around the wrong way here. So I want the hey again. Hey, All right. So how do I verify it's right? Once I've mob it. Oh, that mob. Oh no, is that assembly? I think you can write inline assembly, but I don't know if that's. Sorry, how do I verify? So soon I will be able to so we've implemented, I'll show you, Mr. Levkov. We've put everything in here, of course, minus documentation, but so we've done everything of the splice commands here and it all looks good. So we're down, actually I can update my progress thing. So that's actually, I think it's over 2,000 now. There we go. What the hell is this project, by the way? This is a project to implement a bunch of protocols and messages used in video streaming in pure Go, using as few dependencies as possible. There's some existing Go stuff out there, but why Go? Well, why Go? I guess for me, it's the language I'm most familiar with. Right now, it's at least for the projects that done in Go already, it's working well, and I think I'm finding a really useful language to learn in. At this level, yeah, it's a little bit wonky because I think not doing all this bit bashing and whatever is, yeah. But you know, the other stuff, especially with the concurrency features, not better in C. Okay, there you go. So it's still, yeah, still tricky. I think I need to do it this way. That's what I want. Yeah, if oh, nice. Yeah, that's a really cool idea. Yeah, the ADA, I don't know how you say that, but yeah, like if you could write code like that, that looks really neat and tidy. That's really cool. So, yeah, yes, got it sorted out and have a test somewhere around. Is that it? Yeah. Yeah, seems okay to me. so far. But yeah, I haven't. I would like to. Yeah, have many more other tests. Simple tests, just with a timestamp, what it looks like encoded, and then back again, and just have a few of them at the edges. Have like the maximum. Your accent is what I hear when people say New Zealand. Yeah. I haven't got a really strong New Zealand accent, but the Australian and New Zealand accents are, really similar. But we can tell the Australians and New Zealanders can tell the difference basically instantly. But yeah, about the 33-bit case. As I said, to have a presentation timestamp and to just have things like 0 and at the edges of each of them, that would be really good to test overflow, or not overflow, but when it rolls over, that would be really good. But right now, I'm not. If there's any way that we can think of, that might be easier, clearer way to test it. I think that would be really good, because it's important. Bunch of timestamps in this protocol. Whose accent is the better one? Yeah, I don't know. I really like where I am here. Actually, the sun just went behind the clouds, but usually it's very sunny and warm. It's actually cold at the moment. It's getting into winter here, but it's not that cold. Australia is a long way away from. Yeah, well, here in Sydney, it's a long way away from a lot of places. Yeah, well, that's pretty much what I do. But a lot of people head up over to, just go north in Australia, like all the way north, or of course into Asia, or yeah. Rob Pike produced good content learning. Yeah, I think there are I've found a few good articles. I've got a book that I think is really good too. It's called, I'll just link to it. How do I don't know quite what I'm doing here, but okay. Do I link to it from Amazon or something? I don't know. But there's this. There's this book that I think is good. This thing. Oh yeah, the Inferno. Yeah. Well, I mean, yeah. The language that Inferno was, at least a lot of user space was implemented in, what's it called? Limbo? Is that right? Yeah. If you read Limbo, a lot of it is, really similar to Go. I see a lot of similarities. So even though Inferno didn't become, is now unmaintained, at least we got Go out of it. Imagine if, Java, imagine if we had Limbo instead of Java. Wow, I mean, different world, I guess. Or maybe not. I don't know. I'm just yeah. Do you also I don't know if I'm meant to ask questions to people in the chat. I don't know how exactly that works, but yeah, you know, you don't have to share your information. You know, it's like a privacy thing. Oh, okay. Yeah, cool. Are you also working as a programmer or doing something like that? Yeah, okay, cool. Thanks. Yeah. I don't know how all this stuff works. But yeah, are you also... No, but I mean, like, do you get paid for it? Is it your job? Or, yeah, curious what people are doing out there. See, okay, yeah. Any particular industry or like just any? Okay, tools. Okay. Yeah, cool. Want to switch to Rust, saying Rust is for people who cannot see. Did not come into. What about Zig? That looks really cool. My friend is really interested in Zig. I would, yeah. Yeah, neither. Yeah, I haven't had a real look either. Rust seems very different from Zig, from C, sorry. Yeah, and it's a different thing. Yeah, that's right. Yeah. Yeah, there's a lot of C code out there. Absolutely. I mean, a lot. Wow. turns into assembly. Yeah. Okay. Oh, that's interesting. Yeah, I didn't know. Yeah, I know they were talking about it. I didn't know it was actually in there. Oh, yeah, nice. Yeah. Sorry, this is going to be a really dumb question, but Rust has like a stable sort of, uh, like a stable release now. It's not like Zig or something where it's changing all the time, or I don't even know. Yeah. Oh, that's cool. Yeah. Yeah, cool. Yeah, it's definitely. Somebody explained to me once the theory, because I go to this Go meetup in Sydney. That's the, and somebody was explaining to me the borrow checker and like the idea of it. Sounds absolutely amazing. Like, I think one of those things that it feels like advanced, like actually advanced. I don't know, just computer science stuff. So we're starting to open to using Angular when you first learn programming. Mm-hmm. Yeah, all that sort of thing. Yeah. Hey there. Hey, Pumba. Wow, geez, so many people here. This is so weird. Yeah, okay. Yeah, if other people are interested in that too. I mean, basically, I was. Yeah, I would actually be really interested to hear how. I don't know about how Rust is developed, like like the story of it. Where did it come from, and what are we building? Okay, so yeah, Mozilla was involved, and then all the thing about the Firefox's JavaScript engine was going to be written in Rust and stuff. Wow, like that yeah. Because can you imagine like that C++ all there? Yeah. That's productive. Hey, well, look, I mean, the front ends, yeah. Yeah. Pumba, so what we're working on here is a Go implementation of this binary message format that's used to signal ads when people are playing video. And the motivation for it is, one, just to learn stuff. Also, the other thing is that in previous project I was working on I found and used a few different open source packages, but when I looked under the hood I thought, oh wow, there's actually quite a lot there that probably doesn't need to be there. So I thought about starting a open source project that kind of collects a whole bunch of video streaming libraries into one zero dependency Go module. So this SCTE 35 SCTE35 package is going to be one of those things. Does that? Yeah. So, oh. Oh yeah, packing random. Oh yeah, okay, yeah, just to minimize, yeah, the stuff that goes over the wire. Yeah, yeah, it's interesting. Yeah, I've never really worked much at this level before, as you can probably tell. So it's super interesting to see things where, you know, for example here, I think, oh Jesus, like, can we not just, you know, just use 2 bytes here? No, we've got to use 12 bits and then the next 12 bits, and you know, we've saved the byte. I think, oh, really? God. At least I think that's how it's going. Because you got, you know. No worries. See you, Mr. Levkov. Thanks for checking in. Looking forward to seeing that Rust stuff, by the way. Yeah, you can, yeah. Okay. So, so where we're up to here is, this is the work that we've done before. So we've already encoded we've already done a whole bunch of stuff to encode the commands. So here we get a slice of bytes. Oh yeah, bitmap's still better though. Save as in 2 times slower, worst case scenario based on the test I saw. Bit stuffing. Yeah. One of the things I've noticed about the doing the bit stuffing here is because they're just raw values, there's kind of something about it where, you know, there's not much else that the computer is doing, so you're not the chance for errors is kind of very yeah, you get a totally different kind of error scenario. So oh yeah, cache line boundary by a byte hated so much because I had double the size of memory present. Okay, jeez, wow, that's crazy, man. It's people like you that are keeping the networks running. It's just all magic down there, you know, and everything just works, sort of. All right, so I'll just get going. So command encode. Oh, we got a new follower, it says. Awesome. Cool. Hey there, whoever just followed, or yeah, I don't know if you can see the person. I don't know if you're meant to name them or whatever, but yeah, that's cool. Cool. All right. Okay, so let's keep going here. So we've got the command encoded as a slice of bytes. Now we've got 4 bits that we still need to pack in here. So we can get the length just by, because we've already got a slice of bytes, so we can just do len of cmd, that's cool. So see exactly how we're going to get in there. Len gives us a int. I can't even remember. Yeah. Gives us just a plain int, so we can work with that. So I don't know if I really need to put this in a variable, but anyway. So what we want to do is get the yeah, well, yeah, I guess one of the things about Go and the formatting is that the way it's formatted is it's nobody's favorite. So this is just how it looks. Those are the rules. Okay, so first we'll get the length. Problem is I don't know how long my append okay, sorry. All right, so we're going to get the first. Oh no, let's first get it into a. So we know we have to truncate it, so that, and then so we want the last byte of buffer. It's going to be. -1 or equals you don't need braces when you program? What? How? Oh, because the language that you use doesn't necessarily. No, you said you're writing C#, right? Oh, it depends. Stuff for running 4 bits. I'm just going to put this this message in the chat. I want to put it like up on the top. There we go. Okay, I think, does that look right? Oh yeah. I don't know how to do that though. Oh yeah. Yeah, oh yeah, Google Docs, yeah. Multiplayer, right? Okay, so I think I don't need to do this that way. Okay, Splice command type. So we already have that. So I think now we can just finally append the command. Yeah. Oh yeah, I mean, do something like that. Graphics driver. Do you need braces for doing graphics drivers? Okay, so where we're up to here is packing the, I'm just double checking the, this bit. So we've got, that's right. Toggle, yeah, we do all that toggling, yep. The only thing I'm not sure about there is whether we've lost the No, we haven't. We've just toggled those. Just toggled those bits. Yep. So that's all right. Okay, is it on the command? All right. Well, there's. Okay. So next up would be the descriptor loop length, which we do not actually have any descriptors yet. We haven't done that. So what that would look like would be, we don't need that. Would be a splice info. So we'll just check what this looks like, a splice descriptor. I think there's a whole other structure. Oh no, that's easy. So, okay, so we'll do descriptors, and then this would be an array of a descriptor. That looks pretty easy, and everything's nicely byte aligned there. So we've got 8, 8, 32, 8. Whew, thank God. So, let's, I'll be happy to just put it down here. So descriptor struct is a for the private bytes that make up the body of the descriptor, defined by the descriptor using the identifier. Okay, so that can just be anything. So it's just a unit 8. The length we don't care about. The identifier. You hate reserved bits. You mean because it's like a wasted space? Yeah. Now I'm just thinking whether we even 32-bit field, just seeing whether we actually need any other whether this needs to be set by any users of the package. So we've got a, sorry, I'm just going to check whether you can see what I'm looking at. Oh shit, sorry. There we go. So we've got here the, no, it's still not right. Why can't we, don't know if we can all see that, but I'm just reading this. Zoom in, maybe. Oh yeah, it's a bit better. I'm just checking whether users of the package even need to use this. So this is another one of those times where it'll be really great if we can maybe have like define them as constants but not have them exported, because by the looks of things it may be like that. So it looks like for this ID the value will always be this ASCII QE, QQI, whatever that, yeah, Q insert. I started programming really, I think 3 or 4, really would have been 2019 was really the was the start, yeah, or 2018, something like that. So it was about, yeah, something like 5 years ago now, yeah, something like that. How about yourself? Basically, I started doing things like, like shell scripts, a little bit of Python to automate things in Linux and wherever. But then, what's up, Java for REST? Oh yeah, assembly 1. Whoa, wow, yeah, okay. Yeah, wow. Yeah, I started doing this just because I was writing, shell scripts, but I was missing, you quickly run into limits of shell scripting. So I wanted to know how to, really write your own commands and stuff like that. So, and my friend, he was writing some Python scripts that I found interesting. They were used for a monitoring system. And yeah, yep, that's it. Yep, echo hello world, exactly, yeah. Yeah, that's a good one for the CV, isn't it? Yeah. So just from there, you look at those Python scripts and you go, oh, okay, that's cool. But then when you want to, I guess then for me again, it was that the documentation in Go, I heard about Go because I was interested in C, because I was really interested, I was using OpenBSD. I've been using OpenBSD for years. And I was interested in trying to write programs for OpenBSD without needing to install Python and blah, 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 blah. And so that's how, I started using OpenBSD because the documentation for OpenBSD was really good. So, and because for me, the feel of OpenBSD was maybe felt more sort of, for me, that felt easier, because with OpenBSD, you just install the operating system onto a system, and onto a machine, and then you're good to go. Whereas with Linux, you have like, which distribution do I choose? And you choose your packages and the like the package manager and all this stuff, and then the documentation is inconsistent. So sometimes you can read man pages, sometimes you read Google stuff, and it was all maintained differently. Whereas with OpenBSD, it's all developed in one repository consistently. I started using OpenBSD, I think a long time, 2014, so I guess 10 years ago. Yeah, when I was still at university. Jailbird Linux and improvement. Yeah, cool. I jailbooted for a long time. It was great to get like old laptops and keep Windows on it if you need it, and then install Linux on like a second drive or something, and running on some really shit old machine. Yeah, and then I kind of just did less and less on Windows, and I was happy to play like Open Transport Tycoon and those sort of really basic games. Yeah, I know laptops are it's I know what you mean. I'm on a desktop now, and feels like the way it was meant to be, right? You can just change things super easily. Your own keyboard, mouse, really good quality. Yeah, laptop, you're stuck with a lot of things, which doesn't feel very techy, Which Linux distribution? Yep. Oh, LXQT. Yeah, which is that? Sorry, I'm really out of date with these desktop environments now. So LXQT, that's not like the LX. What was the LXCE? What was it called? LXCD was it called in the day? Oh yeah. LX. Yeah, but then there was another. Yeah, XFCE. Yeah, I remember that for sure. Yeah. Oh man, I installed that on like a Pentium 3 desktop with XKCD. Nah, no, really. There was another one, LXQ. Well, let's look at QT. Yeah, this is the one. Yeah. Huh. LXDE. That was it. LXDE. Ah. So it uses mainly Qt instead of GTK. Yeah, interesting. Yeah, KDE and GNOME, they feel very big now. Using Linux, you can get stuff to run so kind of instantly, and then using all this stuff with like fancy graphics and all these things, it feels, I don't know, for me, it I don't know, it doesn't, maybe not exactly, the editor, like the text editor. Ah, okay, yeah. LSQT actually looks pretty cool, yeah. I really miss that levels and how to revert a change. Yeah, right, okay. Jeez, okay. Yeah, sounds like a lot for a toolbar. Yeah. Yeah. I mean, yeah, here's the toolbar in Acme, right? I mean, this is literally, like, I can just delete, like I can just delete whatever, it's just text. Yeah, so to me, this is kind of like an ideal toolbar in the sense that, you just type like, echo hello world, and then you can just execute it, and then you've got your answer. So, yeah, very simple. And these commands are just, they're just commands. What if every word has a reference to every place where the word is used? Oh, you mean in Acme? Oh, every word has a reference to every place where the word is used. I don't. Sorry, I don't understand. Word, like you mean a word like in computer science, like a word? Or do you mean a word like a natural language word? Oh, okay. You mean like search for a word and it would give you every place where that string is used in any file. Okay. So you mean like a like this? So this is giving me a reference to every place where the string func is used. In this directory, every file in this directory. To move around. Ah. Oh, I see what you mean. Yeah, right. So like if, yeah, okay, I get you. Yeah, so if you had, okay, so if you have like this Wikipedia, and then you would to say defensive, you click that, and then it takes you to something that defensive. Is that right? Yeah. So there is an interesting program called the Plumber that is used in Plan 9 and also in Acme. So, for example, if I type in a URL, like, let's say p9f.org. So I've just typed that, right? And then if I can load that, and then that opens the website. But I haven't, the fact that that's a URL, I mean, it doesn't matter. The plumber doesn't care. I can also do, like an email address. So I could go, like o@olo.co, right click it, and then it takes me to, to send an email. So what you do is, the way Plumber works is, you can define, you essentially define like a bunch of patterns, and then you send the string to the plumber, and then the plumber knows X or EVX and run it. I mean, yeah, sure. I mean, at least with plumber, I'm not sure exactly. So you mean something like, say, like if I had like this? Oh, okay, yeah. Okay, so EVX says, okay, div EVX, like that. Yeah, so yeah, you could, because you could, like do that. What I'm doing is I'm right clicking, and I'm kind of like sending that message to the plumber, but the plumber doesn't recognize this pattern, because I haven't written any rules for that. But yeah, you could sort of, yeah, you could certainly do something like that, yeah. Oh, okay. This is a Splice descriptor. Whoops. Ah, this name sucks. Too long. Anyway. Just because these are plain functions, at some point I can come along and, super easy to refactor into like a method or something if needs be. I mean, even that syntax, like this syntax, you got to point a receiver or a receiver, it could be Splice descriptor, encode. This is just syntactic sugar for for this anyway. So all right. Oh, cool. True round. Hey there. I will follow you back, true round. I just can't remember how to do that. Sorry, I'm really new to this. Here we go. Follow. Is that it? Cool. There we go. Very good. All right. So we're encoding this Splice descriptor. So this should be nice and easy. So first off, we're just getting the tag. I wonder if there's an easy way to just turn that into a slice of bytes. Can we do that? Binary, that's really what I want to do. Oops. At university, I studied medical science. I was going to go into medical research, but I guess I didn't because, yeah, I got a job really quickly in IT, and yeah, just kind of accidentally started started a job, and just never quit, really. Yeah. Seeing now. Awesome. Put. Oh, put you in. That's what we want to do. Man, this seems I feel like there's a quicker way to do this, but anyway, put you in 32 of my buff, and then whoops, we don't get anything in. And then this is going to be sd.id. Yeah. Again, I'm not quite sure whether we can actually whether we need to really export this. I'd really like to just be able to just have that as a constant value, because reading the spec, it looks like we can just have it as a constant value, but again, I'm not 100% sure. I might ask the video dev chat about that. Anyway, and then finally, we'll just do our oh no, I missed a bit here. The descriptor length. So the length is okay, just a simple byte, which is awesome. So next up, we do the length is length. So byte of the length of data. Yep. And then we do the ID, and then finally we just append the data like that. So just reading this boring bit again. Registered by SMPTE should be used. Its use in this descriptor shall scope and identify only the private information. Yeah, I'm a bit lost with this bit. So defined in this. Oh, no, descriptor length. Okay, so we've got the ones that are like the from the public specification. So we've got this type of Splice descriptor, this sort of, and then the identifier. So it may be a, okay, let's get this right. So it may be a, let's call like a regular Splice descriptor, but then it can also be a private one. So that means we do need this uint32. So let's just do this here. So let's define this constant as that. So we'll do this. Is this a Splice descriptor ID? Something like that, public. Oh, yeah, this is a weird part of the spec. Yeah, I know what you mean. Yeah. I know what you mean. Sometimes I know, at least with programming, you feel like you've kind of built something, or at least you've gone ahead a little step. But yeah, at least for me, that's how it feels like. Maybe it's like that for you too. I don't know. I guess, yeah. Okay, what I'm going to do is just comment out all of this old Comcast stuff because, yeah, it's not being used. We may look back on it when we may look back on this particular, where is it? When we need to decode a Splice descriptor. Yeah. It's, well, yeah, I mean, right level of difficulty. Yeah, that's true. Yeah. But also, yeah, sometimes it's too hard because you have too short of a time frame to do it in. I mean, for me, it feels like that. If I have a bit of time and I can do things, I feel okay, but I feel like what makes it harder is you know, when you feel like you don't have enough time, then it gets really hard. Because then you make mistakes that you don't. Yeah. I'm with you. Yeah, absolutely. Make the length of them 32. Might be easy just rather than having a 4 there, I could do a length of. Okay, let's do length of 32 equals that, whatever. Yeah, okay. Just chilling. Okay. Everything takes time because, well, does everything take time? Anyway, I'm not a philosopher. I'm not going to try and get into that. We are very close to finally encoding this splice info section struct, which is Splice info, which is this thing here. Very close now. So let's look at this splice info, see what it looks like again. Yeah, close. Very close. So we descriptor loop length, and then a splice descriptor. Okay, so let's go down to. So we're going to encode. Well, actually, sorry. Let's just, I might have to comment out the old, the package. Oops, what's this? All right, just clearing out the old stuff. Oh man.
yeah, we're really getting to near the end of this. So the commented out stuff is going to be for here down to here. Even all of that now as the old test, which we don't need anymore. And then, oh man, so much stuff. We're almost at the end of this now. I'm just thinking how to deal with all these compilation errors, basically because we're reworking such a core type of this package, this Comcast package. We're getting a bunch of compilation errors, so I'm just thinking whether we're at the point where we can just basically delete all of it, because to give you an idea of what's really going on here, for example, like, you know, this protocol version and the UINT32, you know, like this, the code of the existing package is not great, as I've said a few times. So for example, this protocol version must always be the value 0. This, and it's not a 32-bit unsigned integer. And the same with the tier, that's actually a 12-bit field, so it's not UINT32 either. So there's a bunch of misleading stuff that is oh yeah, no, that's we are, but I've based the work, well, rather, I started off by refactoring an existing package from the net by removing all of its dependencies and then just hacking on the original code. So but I'm almost at the point now where I don't think we really need the like all of the existing code, I think, can almost be thrown out now, and we've kind of ended just doing it all from scratch anyway, in a sense. Just because there were so many like things like this wrong, you know, the sap type and tier, and you can be butterfly now, some type of something, I don't know. Just thinking. What do we think? Should we just throw out the old Comcast stuff altogether? Okay. I'm going to get rid of it all, because we can always, sometimes people are afraid to, it's a good sort of software engineering point. One of the things that I do want to cover in this stream, at least I find interesting to talk about, maybe other people will too. This is one of these things where, you know, you're afraid to delete something, but remember that, you know, we have everything in version control. So if we ever need to look back at something, you can just check out an old revision really easily, maybe in a totally different directory on the file system, and just look at it from there. So I sometimes see that quite a lot, where you sort of
commenting out things and you're afraid, oh, but maybe we'll need it. But just delete, go back in version control. Yeah, found that a really useful method. So here we go. Something I should have done a long time ago. I didn't think we'd be needing to go too deep with the refactoring, but here we are. All right. Oof. In my free time, well, I live next to the beach, so I watched a couple of movies last night. Oh yeah, cool. Which films did you watch? Was it Terminator 2? Oh, what am I doing? Ah, yeah. Terminator 1 is a, yeah, I really enjoyed that. And Terminator 2 was yeah, I mean, for me, I sometimes feel that you have these movies, you have a good, the original, and then the sequel is, usually just, in some way it just doesn't feel as good as the original. But I think with Terminator 2, it really wasn't like that. I feel like it was a great sequel. Like it really took the story and like twisted it, and yeah. Oops. Coding binary. Byte order. Put. Middle of the movies in general, when the heroes doubt themselves and there's calm scenes and they're stalling or having drama with other people. Oh yeah, okay, but heroes doubt themselves. You're having drama with other people. Why do you feel that then? Yeah, yeah. Yeah, that's a good point. Yeah. All right, so we are, where are we up to? So we are, here we go, here's up to a big fight at the end, so they have a speech and then the protagonist. Yeah. Yeah. The hero's monologue, yeah. All right, so let's get the where are we up to? The length of this slice, which is oops. It is length. So right now we're encoding this bit here. So the first thing we need to do is get the length, but then as a but in 2 bytes. So we're going to go. We should be able to do this in one line. Going to get the length of the descriptors slice, but then we want to turn that into do we want to put I was going to accept this. Put the images. We want to get the other way around. Put let's just start with that first. So I know we need to do that. Do I meditate? Man, I'm meditating right now. Yeah, not properly. Every now and then I'll take like a couple minutes and just kind of, yeah, but not really properly, I guess. I don't know what proper meditation is though, to be fair. But yeah, I think the idea of meditation is important. Yeah, absolutely. How about you? Oh yeah. Oh yeah, yeah. Yeah, that I'll do too, yeah. It's easy to not do that, if you know what I mean. Like, it's easy to fall into a habit of just kind of going all the time. So it's cool to take that time to, you know, yeah, relax. Well, not just relax, that's not the right word. To take account of what's going on, I think, yeah. Yeah. Yeah, yeah, you're right, it is, yeah. Because it throws stuff to you, so you don't necessarily have to think like that. Yeah. Whew, okay. So we've yeah. Yeah, well, yeah, okay. Mind emptiness, like by gaming, does that get you a mind emptiness? Is that, am I thinking that? Oh, okay. Yeah. Yeah. Even sleeping for like half an hour, like a nap, can be pretty good to empty your mind. Okay, so we are Just going to double check what that descriptor loop length actually is, because I don't know whether it's actually just the length of the like the number of Splice descriptors, or actually the length of all the bytes of it. Let's have a look. Oops. Oh, 16-bit unsigned integer specifying the number of bytes used in a Splice descriptor loop immediately following. I think, yeah, I guess it would have to be all of them, because yeah, it would have to be all of them. So how are we going to do this? We'll have to maybe probably what we'll do is we'll have to build up another buffer, get the length of, encode every descriptor, get the size of all of them, and then yeah, so we're gonna have to do that. Oh no, we can just do this. So okay, so is buff1 equals append of buff1 to that. So this is actually incorrect. Sometimes, do I think programming is a messy business and you should stop? It is a messy business, and that's a really good word. It's a messy business because the industry is messy. Yeah, like what I'm doing now is, I don't think this is a great way to, I think there's a lot of stuff here that, is unused by most systems, yet we have this huge 100-page specification. We have ways of representing it in XML. Like, do we need all that? Sometimes it gets really annoying that you have to do that. But what would I do instead if I wasn't doing this sort of thing? I've tried a couple of different things, and yeah, I think, yeah. But again, like, the industry is messy, but there is a lot more to it than just writing the code. I think there's more than just programming. I think there's actually a lot more. So, and what I mean by that is that, like, software engineering is a lot more than just writing this code. So I feel like that's really as humans. Oh, you mean like humans disagree with each other a lot? So somebody like, yeah, that's true, but I think that, yeah, look, agreed. The thing is that I think there are quite a few different like principles that will really show through. And that's what I'm trying to explore here, although I am getting stuck with some low-level stuff here. But things like error handling, documentation. Yeah, that's true. I mean, I think we diverge on the implementation, but I don't know. I think there's still bits that we really all can agree on. And it isn't just about agreeing, maybe. I don't know. It's just things that, I don't know. Because I don't think there is one way to do things. And it's kind of like the job never ends. We're always just trying to, optimize it in some way. We're trying to optimize some particular thing. We're trying to optimize like to make it easy to understand, or to make it faster, or to get rid of a whole class of bugs. And I think there's different approaches to all those things and different trade-offs. So I suppose a lot of programming does have a lot of disagreements, but software engineering is more about the trade-offs. And yeah, that's kind of, in a sense, what we're doing here is we're refactoring this package, not because it's not because we need it to be faster or something, but I think this is to make something easier to use. To make this package easier to use. I don't think SCTE 35 is great. I just picked it just because I don't even know why. I mean, I know why, but I don't think it really matters all too much. I don't know if anybody else is listening to this and thinking, what the fuck are we talking about? If anybody thinks this makes any sense, or if you don't think it makes any sense, then please say something. It's funny. Yeah. All right. Let's go back to the code. So we're up to where are we up to? Okay, so looks like we've encoded okay the we've encoded the splice descriptors. Oh, no, we haven't. Sorry, my mistake. The length that we really want is going to be of that. That's what we want. So yeah, 100%. Yep, I feel those things sometimes too. Yeah. Okay. So we will now yeah. All right. So we've got okay. Alignment stuffing is next. Not sure what that is. Yeah, this is tricky. Not quite sure how to use this one. So basically, I'm going to do alignment stuffing. Whoa, all right. Splice info section. Alignment stuffing. Yeah, not quite sure how to do that. You know what? This might be a time to actually. Oops. It is getting late, and we have been going for almost 8 hours now. So. hospital. Yeah. Oh yeah, medical stuff is that's a crazy world. If that's what you mean. So yeah. All right. I think look, because next up is working on the checksums. So at the very end of this, let's actually add that in just so we know where we're going to start off next time. So CRC32. Yep. All right, so let's do this. So CRC. There we go. Right now it is 17:20, so 5:20 p.m. Whoa, 3 a.m. Where in the world is that? Which country? 3 a.m. Oh, Canada. Yeah, cool. Wow, that's cool. Yeah, well, yeah, I might. Okay. One more quick thing. I'll just save. I'll put that there. And then I think that's, yeah, that'll do. All right. So I'm going to start finishing up. So, yeah, as it says, oh geez, that was a good session. Ah, man, yeah. Definitely what I'll need to do is commit and push this stuff so far, because I'd rather that anybody who's watching can just, load at least most of the code up in their own editor or something. I don't know. I think that would be useful. Yeah. But yeah. Hey, Red Zone. Yeah. Well done, staying up so late. You should probably go to sleep 3 a.m., man. That's late. Yeah. And anybody else? Yeah, feel free to follow or whatever. Is it subscribe? I don't know. Yeah. Let's see. Yeah, but that's cool. So, yeah, thanks for helping out. Thanks for chatting. Makes it so much nicer to do this with other people. So, yeah, thanks everybody. That's really, yeah, it's nice. Thanks a lot. As I say, if there's anything else like you think would be interesting, or yeah, I don't know, if something was unclear, or just anything really. I mean, just write it now. I'm very open to any sort of suggestions. Yeah. Just be back in 2 seconds. I'll just put the kettle on because it's cold here. Not cold for the Canadians, but yeah.
Yeah, wow, crazy. Yeah, I don't know. I wondered about maybe should I also stream to YouTube as well? Would that be yeah? Do I need to put up a yeah? Maybe I might do that for next time as well, just do both at the same time, but maybe only have chat open for one of them, because that would be kind of confusing. Maybe just only have chat for Twitch, something like that. I wonder if I should put up a donation thing, because it's, I've been going for almost 8 hours now, so maybe I don't know. I do need to get paid sooner or later, so my girlfriend will kill me if I'm not earning money soon. So yeah, I'll definitely put up a thing saying if people want to hire me, I'll put that in for sure. Let's see. Just looking to see where to put this in. Here we go. Oh, 1 hour of sleep? Does that even count as sleep, or is it just like But then do you sleep a lot the next day? Like 12 hours or something, or? Seven hours? Okay. Yeah. 7 hours is seems okay. Although they do, I know I'm interested in the quality of sleep. There's definitely some interesting research around that at the moment.
So I'm just writing a donation thing. I'm not sure how this not the donation, sorry, the donation, I'm talking about the hiring thing. Let me just do that. Okay. Yeah. All right. This this looks. Yep. Yep, this is good. All right. All done. All done. Okay. I'm going to be doing the same thing in about 12 hours time. Sorry, 14 hours time. So if anybody's around and wants to continue, I'll be here. So thanks again, everybody. Thanks for sharing your time with me. And yeah, let's keep it going. It's great, really fun. All right, see you. Ciao. Thanks again. Thanks. See ya. Sleep well, hey? Bye.